What's going on in here? Good day to everyone.
What's up, Jemsy?
Hey, Yoder.
Got a guy in the chat who seems to be hung up on math and math only.
Math only.
Yeah, he did math. He performed trigonometry to determine the angle of dip through the chord of the earth, and says because he could perform this mathematical operation, then Earth has to be a globe.
Whoa.
Now, it's within the context of neutrino emission and detection. So I'm like, all right, convince me that this is actually possible. What's a neutrino? And he seems to be doing everything he can to begin with that. Before we can even get into like how does neutrino emission work and how are neutrinos even detected, I just want him to describe what a neutrino is. He's doing everything he can to avoid having this part of the conversation.
And remember, there's trillions of neutrinos passing through your body every second, but they can detect specific neutrinos.
Some.
He's sitting in VC right now. Won't open the mic.
Come on, bro. Help me out. I want to buy some neutrinos. The trillions of them passing through. I mean, should be fairly cheap. Actually, yeah, just tell us. I mean, he got the math already. Where are you getting the math from? Like, can you show?
He could probably MS Paint some of it.
Yeah.
Here, let me one up him a bit. I'm going to present his own math. Look, you can draw shit.
Are you actually there?
Oh, I'm actually here. Yes, I am actually here. Well.
Yeah. What's a neutrino?
Doctor.
What's a neutrino?
It's a particle.
A particle. That doesn't tell me anything. What's a neutrino?
Particle. Somebody asked me what light is. I'm going to say a photon. They're like, that doesn't tell me.
No, I'm asking you what a neutrino is, dumb fuck. Come on, what's a neutrino?
What is math?
All right, so you're bricked. Got it.
I have the same question. What is that? A neutrino? What's that? Sir?
Neutrino?
Yeah, what is that?
I told you. It is a particle. Like, do you want, like, what do you want me to say? Like, it's like ask me what light is. I say photon. You're like, well, what is that? It's a photon. Why are you getting so hostile, man?
Hostile? I'm being hostile.
Doctor is.
I'm being peaceful.
Are you mad that like people can actually do math?
Mad?
No, I'm just upset at dishonesty because I don't think you have any idea what you're talking about.
They were talking about like the experiment, or like they were talking about this experiment that happened in Illinois and like Minnesota.
All right, what's a neutrino? How was it discovered or invented?
Well, I don't know how it was discovered, but I do know that it's a particle.
How do you know it's a particle?
Because that's what we call them.
So you have no idea what this is. Classic dodge. Classic dodge.
Dodgy, dodgy.
What will be an example of a neutrino in the physical and natural world? Right here, neutrino.
It could be like an electron, or like that could be it.
An electron is a
Like
neutrino?
an electron.
Well, they pair with like electrons. Oh, God.
They pair with. Excuse me, what?
Yep. Did you not know that?
They neutrinos pair with. That's what the audience heard.
You never heard of an
Yeah,
electron
can you repeat
neutrino?
yourself? They pair with what? Can you say that again?
I said it's an electron neutrino.
Oh yeah, what makes it an electron?
What makes it that way? Well, it would have like no electric charge, right?
Oh wait, I thought neutrons had no charge.
Not the electric neutrino.
Oh, it's electrical?
Mm,
But it's electrically neutral, but it's electrical. Yeah, go figure. It's electrically neutral. That's why I call it a neutrino. Duh. Now you're telling me it's electrical. How do you know it's electrical when it's electrically neutral?
I'm just a pilot.
Yeah, you're a pilot. Okay, so you're talking out of your ass. You
But I
could
do
just
know
say,
how
I
space
don't
missions
know,
work.
and be honest about this topic.
Hmm?
I mean, have those words ever passed through your lips before? I don't
Bro,
know.
he heard you saying you could be honest, and he's like, huh? That doesn't compute or something?
Well, he's a pilot, so.
Yes.
I mean,
Yeah,
but
that means you're at the
how can
top
you
of the food
say
chain, right?
when someone asking you, can you be honest? You're supposed to say, yeah, I could be honest if I wanted to. Or you could say, no, I cannot be honest at any
Well, it's
point.
kind of like a weird conversation.
Yeah, it is weird. I mean, you came in here describing a neutrino event, and you don't
You're
even
trying
know
to
what
tell
these
me
things
some
are.
things don't exist, okay? It's not a worded conversation. It's like
No,
telling me
no,
gravity
I did
doesn't
not
exist.
tell you they don't exist. I asked you to convince me that they exist because I want to see how much you know about it, Mr. Knowledge.
Of course they exist. They interact with gravity, right? They're like in like the weak nuclear like force.
They
Right?
interact
Of
with
course they do.
gravity? How do they interact with
Right.
gravity?
How do you think?
I'm asking you, bro. This is your topic.
You tell me.
You told me they interact with gravity. I'm like, oh, cool story. Tell me how that works. I'm very curious. Tell me all about neutrinos. Go ahead.
Well, do you think that gravity affects mass?
Okay, so dodge the topic.
You were supposed to tell him how Is that is the case? Not asking him a question.
Yeah, you told me they're electric and there's like actually no electromagnetic interaction at all with neutrinos, which is freaking hilarious. Now you're telling me
Well,
that they interact with gravity, and I'm like, okay, great. So how much mass do they have?
they actually have the least amount of mass out of all the others.
Oh yeah, how do they know that? How do they? In what units do they detect mass of neutrinos?
I don't know that.
Oh, okay, good. Some honesty here. It's electron volts. Please tell me more about neutrinos.
Please tell me more about your flat earther.
Well, I can tell you as a pilot, you've actually never seen curvature of the Earth before.
Is that true? Why do you think that like my horizon like drifts the further I climb? Why do you think that is?
Because you have a wider viewing angle of the surface from higher up.
That wouldn't be true on a flat earth. You know that, right?
No, that is absolutely true. You can
The re-
demonstrate this on something as small as a chessboard.
the
If you view
reason
a
why
chessboard at a very oblique angle, you won't see the edge of it. But as you
there's
raise yourself higher than the pieces, then you can see the edge of the chessboard.
so you're saying on the flat earth model, like what's obscuring my vision like then? Like why how's that explained on your model? All right.
I don't know, it depends what you're talking about. Obscuring your vision, like what do you mean obscuring your vision?
Yeah, human vision is very limited.
So like
Vision of what? Vision of what?
what I'm saying to you, like, would it be any difference if I'm on the ground or I'm up in the air? Like, if can I see past the horizon on the ground?
What horizon? What are you calling a horizon?
What do you think horizon means?
I know it's an optical phenomenon that's, due to your environmental factors and your limitations of vision.
It's it's a what?
Yeah, it's an optical phenomenon. It's where your mind draws a line that separates the sky from the earth.
So what's obscuring my vision at the horizon?
A combination of factors. You want me to repeat myself? Environmental, as well as limitations to your biology and your own perception.
Which you said the higher I go, I can like see further. Why is that? Why do you think that is?
I told you why, because you widen the angle of view to the surface that you're viewing.
Is it because I'm going above the curvature of the earth at that point and that I can see past the
What
horizon
curvature? What curvature? What are you talking about?
What
Where does curvature factor into the horizon?
So because the horizon is what is skewering my vision, that curvature. Okay. When you say I go up, okay, what I'm doing is I'm going over the curvature at that point, which is the horizon, which allows me to see past it. Okay. That's not true if I don't go above it, right? That's the reason on the flat earth model, like
So
there's no such thing as your vision being obscured at the, like you would be able to see distances both no matter where you were. Like if you were 10,000 feet up in the air or at ground level, there would be nothing obscuring your vision.
No, that would be incorrect. That violates physics.
I agree. That's why I don't believe in it. I'm not a flat earther. So you're saying that like if I go above that curvature, like right, which if I climb high enough, right, I can see past the horizon. Yeah, that's true. That's because I'm above the curvature at that point at a certain altitude, right? That which it's no longer obscuring my vision.
You know, they took a picture of Earth, guys.
Horizon doesn't. I mean, the edge of the ball doesn't obscures your vision. It blocks your vision. The obscure part will be maybe weather conditions or medium conditions, or maybe your eyesight conditions. So you're saying something that doesn't make sense.
So like if you're about like 5 feet above like the ground,
Listen,
right?
listen. If
like
you
the
if you
horizon would
if
be
you
roughly
if you
3
see
miles away,
if you
like right. If you're standing at like 10,000 feet, the horizon's about like 126 miles, like right.
On a globe, yeah, that should be the case, right? Yep. So
Yeah.
let's say we have a lake, right? Beautiful, clear day, clean conditions, no wind. We set up a camera at 5 foot height, just above the surface of the water. Horizon should be about 2.7 miles away on a globe. And any water that's beyond that 2.7 mile horizon should be physically obstructed and not able to be seen, right? Knowledge? Acknowledge?
What's that? Smoking.
It's terrible for your health.
Yeah, I gotta get me
You're
through
good.
this.
I'm just joking. All right. Did you hear what I said though?
Nope.
Okay. Right. So if we go to a beautiful lake, right? There's no wind, nice clear conditions. We set up a camera 5 foot above the surface of the water. The horizon should be about 2.7 miles away. 2.73 if you want to be precise. Let's just say 2.7.
Yeah.
All right. So any water beyond that 2.7 mile horizon should become physically obstructed behind the curvature of the Earth.
Well, like
Do you-
if like ships were like sailing away over like that distance or whatever, like they would never like appear to sink from like the bottom up, right? They would be fully visible, right?
No,
Yes.
on a globe. I'm talking about a globe. On a globe.
But what we see at those distances, that it's the bottom up though on the globe.
Yeah,
That's
right. So exactly right. So that's, you agree with what I said then?
That's not what we see in your model. Though. That's not what we see in reality.
No, it's not ever.
They don't remain fully visible. They sink from the bottom up in reality when you go see it, right?
Okay, I'm trying to get you to agree with me. I'm talking about your model. I'm talking about the globe, because that's what we're going to test.
It's not
Okay,
my
so
model.
no, the globe model. Not you. You're not. It's not your model. It's just the globe. Right?
You mean everybody's
The
model?
It's not everybody's model. It's just if the Earth's a globe with a radius of
99.9% of the population.
No, it's not that, right? But when they do surveys, right, it's actually completely different than that. So that number that you said is incorrect compared to the surveys. But we don't need to worry about that. Let's just stick with the test, right? So if we have a lake and we have nice conditions and we set up the camera at 5 foot height, the horizon should be about 2.7 miles away on a globe. Do you agree?
Did you say 5 feet?
Yeah, 5 feet above the surface of the water. That would mean that the horizon should be 2.7 miles away, approximately.
Have you guys broke off a piece of the firmament?
No. We don't just jump in and say yo and interrupt conversations. I'm having a nice, friendly conversation with my friend Knowledge right here. Right. So, do you agree? Do you agree, Knowledge, that the horizon would be 2.7 miles away approximately if you set up a camera at 5 feet high above the surface of this beautiful, calm, clear lake? Nice day. shiny water.
Yes, yes, sure.
Yeah, you can agree with me. If the Earth's a globe,
Yes.
right? And then, right, let's say we had the Titanic, right? It's about 175 feet tall, approximately, something like that. Right. So let's say the Titanic was docked right next to the camera, and now the Titanic is going to sail away to the other end of the lake. Let's say the other side of the lake's about 20 miles away. Okay. Now, once the Titanic sails away from the camera, it's going to get out to where I can see the horizon line at about 2.7 miles. As it starts to go beyond the horizon line, the bottom of the Titanic will start to become obstructed behind the curvature of the Earth. Once it gets to 10 miles, the bottom 66 feet. Oh,
Are you
sorry,
taking
we got to
taking like
take the observer height into account.
are you taking refraction into account?
I'm talking about just the physical obstruction at this point.
Okay, but the distance changes when you take refraction into account. Like, right? So even if you do
Right,
say
right.
it's
So right now we're
2.7,
just
it's not actually 2.7, is it? No, it's not.
what
Not
we're
when you
talking about. No, listen. Right. So right now we're just making sure we can both agree on the geometric features, right? Independent of the atmospheric conditions. Just so we can agree on what should physically be obstructed. Notice I said physically.
yeah.
Yeah, physically obstructed. So the bottom 46 feet of the boat should be physically obstructed, or probably even. Well, I could check the exact math, right? But let's say by the time the boat gets to the other side of the lake, 20 miles away, should be completely hidden behind the curvature of the Earth. Just physically obstructed behind the curvature of the Earth, because there's 266 feet of raw curvature over 20 miles on a globe. Right, that's what should happen. Okay, now tell me what you know about refraction.
Well, it's because the air is denser near like the surface of the Earth, right? It's like a giant lens, right? And like the light rays like downwards towards the ground, right? So like when you take like the curvature into effect, right? Like those distant objects and like in the horizon, like they'll appear like slightly higher and closer, like to your like what you see.
Not quite, right? So temperature, pressure, and humidity is what's
No,
going to
it is
be. Hold on.
the air is denser near
Hold
the
on. I
surface of the Earth.
let you finish. Even though what you said was incorrect, I let you finish so I could
It's not
then
incorrect.
talk. Oh yeah, it is actually incorrect
So
because
is it?
you're just taking the atmospheric pressure into account, right? And that's higher as you get lower on a broad scale, right? It gets thinner as you go up in altitude, right? Now, that's not what controls the refractive index in the lower troposphere. It's the temperature that's the primary controlling factor of the refractive index. Of course, we're talking about optical density. Okay? Now, you can look this up any way you like. Temperature is going to be the primary controlling factor. That's why we have atmospheric refraction, right? It doesn't necessarily bend downward, right? It can bend upward. We have opposite effects. So you should be able to agree with me that light will just bend towards the higher refractive index, right? Kind of like in Snell's law or in the differential equation of Snell's law, if we're talking about a gradient medium. Wherever the gradient has a higher refractive index, which is the optical density, the light's going to deviate towards that. Do you agree?
I guess, yeah.
Yeah. So it could bend up, it could bend down, it could not bend at all if you have like a neutral density gradient, which is pretty rare. But temperature is going to be the main thing that controls the density of the air lower to the ground.
Well,
And then
well, like I understand what you're saying. Like just like normal refraction, what you're saying. Like instead of like the 2.7, it would be like roughly 3. Like so when the cold air, like what you're kind of like when it sits directly over like
Like,
cold water over like a warm layer of air, like that that can make like dozens of miles. Like
like,
you can see past like the horizon, right? like what you're saying. I mean, I get what you're saying. I don't.
Okay. Look. So look. This is what they claim
I don't disagree with you.
in the if the surveyors, right? So surveyors just kind of guess the refraction. So they just take standard refraction into account. They just assume it's bending downward a little bit, and like you said, instead of the horizon being at 2.7 miles, it would be at 3 miles. Let's say, like 15% is approximately the 0.13 refraction coefficient that they use, right? So it's like 15%. So yeah, it's 2.73 miles plus 15%, even though that's just a guess, but let's just go with that.
It's
Okay, so
actually
let's just say 3 miles, including
it's not 15.
it is 15. It's a 0.13 refraction coefficient.
For normal.
So you could
for normal, like
this is just normal. Like, so once we get into normal, like this is the problem. There's papers saying how ridiculous just having a standard refraction is.
show me the paper.
Because if we get into what's normal, if we get into what's actually normal, the lapse rate actually decreases in temperature with height. So the normal wouldn't even be light bending downward when we're looking through a very small gap in this atmospheric density gradient that decreases with height, because it hardly decreases at all over this tiny little 5-foot window we're looking through. So that's why they say temperature is the primary factor that you need to take into account. So temperature actually decreases with height. That's the normal lapse rate. So if we're talking about the normal, then it wouldn't be downward bending light. But I can grant you that because we got lots of wiggle room when we go and do observations. So let's say the horizon should be around 3 miles with refraction taken into account. Because let's say we have a beautiful clear day and there's no sign of any miraging effects or like crazy atmospheric refraction. It's just a nice clear day. Everything looks pretty normal. We have pretty neutral temperatures with the water in the air, that kind of thing. So let's just grant you the refraction, standard refraction. Horizon should be around 3 miles, right? So when we actually go and test this, it doesn't do that, right? We can see the whole way across this 20-mile lake, and there's no horizon at all present over the whole lake. And then we test it again at nighttime to see if, maybe there was some crazy atmospheric conditions taking place. And once again, we see the whole way across the 20-mile lake at nighttime. And we can see the shoreline on the other side of the lake.
Can you show me in the side chat, like what you're talking about?
Yeah. Okay. Just give me a second. I'll just pull it up. It's actually 21 miles, this observation. I was just saying 20.
I'm just saying, when you say like observation, like I'm not just going to take your word for it.
Of course not. No. Yeah. Trust me, bro. Trust me. Why would I lie?
No, I'm not saying that you're lying. I just want to know.
No, I know.
So
I'm just joking. I'm just making small talk.
I would never say you were a liar.
All right, so this is all out of a full-length video that's in high definition, but I have taken some clips and some screenshots from the video save you having to. Yeah, I just took them from the video so I can present it without us having to sit through a long video.
I want to watch the full video.
But okay, if you want to go and watch the full video, you should let me present it first, because the guy in the video doesn't present the actual long distance observation as well, because what they also do is a laser test, and he focuses more on the laser test, where I just consider the laser test like a bit of icing on the cake. So let me explain it, and then I'll post the full video, and then you can watch the full video. I'll just give like a really quick presentation.
Are they laser beams? If not, I'll be disappointed.
Are they what laser beam? I'm not talking about laser beams.
Oh.
So I'm just talking about what we can see.
Hey guys, if you don't mind me cutting in, I had a work call, so I had to bug out there. Sorry about that knowledge.
Who said what?
We were talking before about neutrinos, and I had to bug out due to a work call. Because yeah, despite popular belief, We are employed.
I never said otherwise.
Okay, well, there's a popular trope out there that apparently we're a bunch of booger picking retards and are unemployed, and that's not the case.
I'd say the correct word to use is skeptic, but not like right.
Yeah, you're right. Listen, you've been very polite, and I'm sorry for being harsh with you earlier.
Nothing wrong.
We gotta tune down the use of the word like, though. I think it'd be better if we said that
R
a
word.
little bit less.
Yeah, the R
All right,
word too rolls off the tongue.
let's change it a bit and let's use the word lake a lot. L-A-K-E. All right, so let's get back to this lake. All right, I'm going to post just a little clip right now. So pay attention to the side chat. All right, obviously there's going to be a lot more than just this little clip. All right, so this is the camera set up at 5-foot height. The target shoreline is 21 miles away from the camera. Next slide, we have a top-down view with the Google Maps distance marcation tool showing you that's where he's standing at the top of that yellow line there, and he's zooming across 21 miles away to the distant shoreline. Now, he has a buddy over on the distant shoreline, and here's a close-up view of what it looks like. So this is where he's going to be zooming into. Take note of the big white smokestack. Take note of the target, which is the shoreline, the big shoreline. We can see some little streams or puddles on the shoreline as well. All right, now next we have back to the camera side of the lake. This is the camera setup, 5 foot above the surface. And here we have just the basic math, not taking any refraction into account. 5 foot eye height, target distance 21 miles. That means the horizon should be 2.7 miles away, and the shoreline should be hidden by 223 feet. But like you said, we can stretch that horizon out to 3 miles, no problem, by adding in some, standard refraction. As you can see in the video, we have pretty clear conditions. We don't have any crazy refraction going on that day. No miraging effects or anything like that. Now, I'm going to post some still shots from the observations. All right, so once again, we have the close-up of the distant shoreline. And then in the second image directly underneath that, we have the daytime zoom from 21 miles away. All right, you'll notice that we can see the entirety of the smokestack, and we can also see the shoreline on the other side and the bank. And then he did it again at nighttime. Here is the night shots, even clearer. So we can see the shoreline. We can see the light reflecting off the little puddles on the shoreline. And we can see the entirety of the smokestack. And zoomed in a bit more, right? So this is the close-up picture of the smokestack again. And here is the 21-mile zoom screenshot from the video, where you can see the shoreline, you can see the bank, and you can see the entirety of the smokestack. Now the shoreline should be hidden behind about 200 feet, 223 feet. Taking the observer height into account, if you want to add the standard refraction, that's fine. Doesn't make much of a difference. Let's say approximately 200 feet. So 20-story building of curvature completely missing. And we don't have any horizon over the entire 21-mile distance either.
Okay.
So this black line, that's approximately where the horizon should be if the Earth's a globe. You can stretch that out to 3 miles if you want. I mean, even if you stretched it out to 10 miles, it's just not there over the entirety of the surface of the lake. Here's another Google Earth screenshot just for fun. So after this, they did do a laser test as well. they set the laser up at 5 foot height. Here's a picture of the laser transit. And his buddy, John, I think his name was on the other side of the lake. And he was able to detect the laser from the other side. Here's the laser being detected. Like I said, the laser part of the test is just like icing on the cake. I prefer the visual observation because it's just easier to follow along with. I mean, we can just see with our own eyes that the horizon's not there and the curvature, like the obstruction's not there that would have to be there if the Earth's a globe. So this is the kind of observations that we have plenty of. Anyone can go and do these themselves. And we have hundreds of these where every single time there's no curvature where the curvature should be there. So the math might work for the globe model and be internally consistent. But when we actually test it in reality, it's not consistent. It's actually the curvature, the math doesn't match reality. And we encourage people not to believe us and just to go out and check for yourself because it doesn't require any faith. And you can just go and test these things. And when I first heard about this, I thought it was stupid as well. So I went and tested it myself at least 15 times because I lived on a giant lake in Australia. And I was able to test it. So yeah, there's one test out of many.
So 21 miles is 294 feet. Is that right?
Yeah. Mm-hmm. Approximately.
So, like, you understand refraction, right?
Yes, very well.
So light rays, like, they travel horizontally, right? And they bend towards, like, downward towards, like, the Earth, right?
They also go left and right. The same degree is up and down.
If they're
They
bending
talked
downward,
about this earlier, by
like,
the way.
yeah, that's
Yeah, we went over this.
curvature,
I talked about this with this guy earlier. We already went over this. Yeah, so what's standard refraction? We already extended the horizon. We already accounted for your standard refraction. Even though light doesn't necessarily bend downward all the time, it can bend upward too. Okay, but we just granted you some downward bending refraction because we don't have any miraging effects taking place. We don't see any effects of heavy refraction. Right? So I granted you some downward bending light, which is exactly what surveyors use worldwide, 0.13 refraction coefficient. So that just makes the horizon 3 miles away instead of 2.7. And that makes, instead of 223 foot of hidden height on the shoreline, now it's like 200 foot of hidden height instead of 223. So instead of a 24-story building missing, now it's just 20-story building missing. And if you wanted to claim refraction could cause 294 foot of curved water to just completely flatten out with no miraging effects, with no crazy distortion effects or anything like that, not only during the daytime, but also during the nighttime consistently as well. And in all of these other observations we have that have been done all over the world in completely different weather conditions, I'd say that that's an extraordinary claim, and extraordinary claims require extraordinary amounts of evidence.
If I could pile on, it's not just the vertical displacement that's a problem, but it's the horizontal displacement with respect to the vertical. Because this means that you also have a distance, okay, that you think is curving around a ball. And every point along that ball surface distance has to refract at a different rate of change in order to conspire together to produce a stable and flat image. We're talking trillions of photons taking independent paths that somehow conspire together to go from a curving surface to a flat and stable one. And I think that's a conspiracy theory, dude.
Okay. Did you calculate, like, the air temperature and pressure when you did this?
No, the question is did you guys do this when you came up with the standard refraction coefficient of 13% that we're correcting for?
Did you calculate it?
Do you even know what you're
No,
saying,
we're
bro?
look, we're not making a specific claim here. We're not saying this observation proves the Earth is flat. We're just saying we all experience the Earth as flat, right? But we get taught that we're so small and the Earth's so big that you wouldn't see any curvature. So we're calculating specifically based off your specific claim how much curvature there should be over this distance. Okay, and then we're taking your standard refraction and we're applying it to it.
How would
Okay,
you know
and
that?
all we're
How would you
detecting,
That's
all
right.
we're detecting
Refraction's the
is
excuse.
zero.
How would you
Yeah,
know
it's
that
all we're
without
detecting.
calculating the air temperature and pressure? Like in cold air is dense, right? Like warm air is like thinner, right? So
Yeah,
light travels slower in dense air and faster, like in like the thin air, right? So if in
yeah.
these
So
images, if you're not calculating that, then like it's going to appear distorted. It's and
You
wrong.
keep saying
yeah, so
calculating.
it's
You
not.
probably mean measuring.
Hmm?
So check this, right? So what you've just done is you've made a claim, right? So we're just showing you flat water over 21 miles. Okay, that doesn't align with the globe. Now you're claiming that really there is a physical geometric horizon at 2.73 miles, but there's some amazing refraction effect, right, caused by the refractive index gradient of the air that's able to flatten out that 294 foot of curvature and completely hide the geometric horizon from detection consistently during the daytime and during the nighttime, and just
Right,
make
so
it
the
all look
question is,
flat.
how do you know it's there in the first place? Well, you're the one that has to provide the measurement.
Yeah, you're the one.
No,
Yeah,
I'm not.
because you're the one saying that something is there that nobody can detect.
No, in order for these images to be accurate, you have
Yes, you're
to.
saying the curve is there and nobody can
There is a
detect it.
massive temperature difference when you go to like a
Oh,
great like lake.
really?
Yes.
Really? Okay, there's a massive temperature difference. Great. Okay, I want to see evidence of that.
If you don't calculate it into like the
Calculate
equation,
what? Calculate your
then
fantasy? No, you need to measure something real.
are you saying temperature is not real?
No, you need to measure it. You don't calculate. You've got to measure something. Listen, calculations produce video games. Like, the Superman flight simulator is an extreme version of calculation, right? How do you know that this is real? Well,
Because
you got to
the
measure it in reality as a benchmark. You don't use calculations and models to benchmark claims against. You use reality.
Okay, but density differences bend light differently. Okay, over open water, air forms layers of like different temperatures, right? Light
Yeah.
passing through these like layers, like
Nobody's
bends. That's called
disputing that. So
that's
do
the
you have that?
Did
Good. So we're
he do it?
expecting you to provide that.
Did you do it in these images, Mr. Doctor?
Why
Did
do
you
we need to
calculate?
produce it? This is your rebuttal.
Because it's not accurate if you didn't do that.
How do you know
We're not
that? Okay,
making.
fine. Go ahead and produce an example for us.
He's the one
Yeah,
who
he doesn't
right?
seem to understand what's going on here. We're testing your hyperspecific claim, and all we're seeing is flat water. Now, what are you claiming
What
is
are the
can you
temperatures?
see
What are the
hold on, listen.
taking at
Can
this
you see any listen, stop.
What's the temperature? Show me the temperature. Don't show
This
me the
is
distance.
no, so you're not getting it. You're not getting it. So
I don't
that's
care.
because you're spazzing out right now. Your brain's shutting down and you're going into cog dis mode, right? This is your way of trying to exit the conversation by just turning it into chaos until you get
You are
muted.
a moron. You don't understand
No,
refraction.
so just attack the person
This
instead of
guy
the
said
argument.
he agreed with me
Yeah,
that
cope
cold and light
harder,
like the
bruh.
density like is different. Like I need to
Listen
know in the images in the
more
night
and talk less.
I
I
don't know
haven't
the
muted you
temperature
yet, but I'm going to start, right? So I'm going to tell you
Go fuck
something right
yourself,
now.
retard.
We're not
You're a
claiming
moron.
this to be
Yeah.
Bro, you work for Pelosi. You have no room to call anybody anything at all.
I own a
This is
consulting firm.
hilarious. He just started calling you a retard for no reason.
Yeah, this is right. So this is being streamed on YouTube, and then these get clipped and they go all over the internet and get hundreds of thousands of views. And you're not making a good appearance right now.
I'm totally
Who
clipping
cares,
this.
dude? We're on fucking Discord in a VC. You act like this is something
I'm clipping
prestigious.
this.
It's not.
I'm clipping this, and I'll show it to future generations.
That's fine.
Yeah, so Twonga, these clips,
If
right? So
you
it's on Discord. Knowledge, shush, hush for a second.
no,
Okay, so this is on Discord now. We don't have a lot of people listening. It's being streamed on 2 YouTube channels where there's also not a lot of people listening. Then people take the clips of these golden moments with globers, and then they push them all over social media platforms that get huge views on X, on Facebook, on TikTok, and it's not just once or twice. They get spread all over the internet. So maybe in 5 years from now, this conversation will get 1 million views or more. So you can cope all you
Children
like.
will be embarrassed for your sake.
So Twonga, this is what happens when you act like a bitch. Doesn't work out for you. See you in 2 days, my friend. All right, Knowledge. I'm trying to explain to you that we're not making a claim here other than testing your claim. And your claim is that there should be 223 foot of hidden height to the distant shoreline, and there should be a geometric horizon at 2.73 miles. Now, you're claiming refraction is making it all look completely flat. Do you have any evidence that that's possible? And now we're going to get crickets. Do we have the cricket sound effect for Knowledge? Yeah, thanks for playing, Knowledge.
I don't want to talk to you. You're an idiot.
Oh, yeah, great rebuttal.
You tried to tell me
Great
that
rebuttal.
you don't
Says the
calculate
guy who
pressure and
willingly
air
joined a Flat
temperature.
Earth Discord channel.
You just told me in order to like know if these images are like accurate or not, you have to know the air temperature and the pressure. You have to calculate.
No,
you
you
haven't told
don't.
it to me. Yes, you do.
No, you don't need to know that. You don't need to know that because there's
Yes,
so
you
this is
do.
what we can do. Yeah, this is what we can do. Okay, we can
The
reverse
horizon.
engineer it. We can reverse engineer it based on globe, right?
Would you
Based on
agree
globe
the
nonsense.
horizon
So listen.
moves every single day? Hey, dumbass, the horizon
Yeah, how
moves
far does
every
it
single
move?
day.
Yeah, how far
Cold
does it
water
move?
and warm air. Light curves deeply around like the Earth, right?
Yeah, how far does the
Okay.
horizon move?
Light bends
How far does the
upward
horizon
into
move?
space.
You just
Okay.
said the horizon moves, so how far does it
Okay.
move?
You tell me.
How far does it move?
You tell me.
Well, according to standard refraction, it just moves by 15%. And then heavy refraction can be around 30%
If the
or
horizon
40%.
moves every day, the light travels like slower
So
or faster.
this
depending
means you
on
can't see the
temperature.
curvature of the Earth, Knowledge. You're telling the whole world that nobody can see the curvature of the Earth.
You said that you can.
No, you said
don't
that
have to
it moves
calculate
around,
that.
so we don't actually see the curvature of the Earth, do we?
Wow.
Like this guy is an idiot. Go back to the other guy.
No, you're telling
Did you
us that you
say
can't
this
see
guy
the
is an
curvature
idiot?
of the Earth. So how do you know it's curving in the first instance?
I don't want to talk to you or the refraction
I
guy.
know, because it's a difficult question that you fail to answer, right? Because you're giving us all reasons why we see a flat Earth.
Who was the guy I was talking to before? The nice guy.
You were talking to me
That
before.
was,
No, I wasn't.
I think, no, that was me. I just changed my name to Refraction Jackson. Yeah, I can also be a prick when you start being dishonest.
I'm not being dishonest.
So you're telling me that it curves so much the Earth looks flat and you can't see the curvature of the Earth. Is that right, Knowledge?
I didn't say anything. I don't know what you're talking about.
Yeah, you told me the horizon moves around all the time, so you shouldn't be able to see the curvature of the Earth, right?
So
I think he needs a lawyer. He needs a lawyer now.
He's
Just
lucky a
before,
lawyer just
when
joined
you
the
were
chat.
talking to me, you were saying that the curvature of the Earth is the horizon. Now you're saying it moves around all the frickin' time.
You are a moron. Be quiet. You literally said that neutrinos don't exist. You're an idiot. Be quiet.
No, I asked you to prove that they do exist. That's a whole different question.
I don't have to prove anything to you, dude.
Wow.
What was your claim?
He didn't say they didn't
Your
exist.
voice is audibly trembling right now, Knowledge.
No, because this is a
You're fucking terrified.
No, you
The
are.
burden of proof is squarely upon your shoulders.
You better take some more bong hits to deal with this cope session,
Tell
Knowledge.
me that in order your images that you've taken, right? You told me that I don't have to calculate the air temperature, rather it's cold or warm air over these lakes. Yes, you do.
No,
Oh, so
you
that's why
do.
it looks
It's
so flat all the time,
No,
knowledge? That's why it looks flat?
what's happening here is that if you do, your images are going to be wrong. That's the reason why you can't say
No,
that.
that's why it looks so flat, right, knowledge? Why don't you just say that's why it
Hold
looks
on.
flat? Can you tell the audience that this is why you think it looks flat?
What are you talking about, dude?
Does
You're
it look
telling
flat?
us why you think it looks flat, because light bends.
This is excellent.
What are you talking about?
Oh yeah, what are you talking about? Oh, I don't understand basic English anymore. Does it look flat? Why does it look flat? And does it look flat? Do you see any curvature in the observation? Did you see any geometric horizon or any horizon over the 21 miles? Yes or no?
That's because you're like on a two-dimensional manifold here. Like if you scale it out, like if you go towards
Right,
like
so the sphere Earth is a two-dimensional manifold. Got it.
no, what you showed in the images, that's a flat plane.
It is
You
a flat
understand that?
plane.
Damn
You
Skippy.
got something right.
A two-dimensional manifold is a flat plane.
Yeah, but you need to specify what kind of manifold, dipshit. If you said a spherical manifold, then there'd be a mismatch between Cartesian Euclidean geometry and the geodesic spherical manifold geometry, wouldn't there? Right? This could be calculated in something called the transport rate, as you take one vector and you notice an increasing divergence along another vector.
Okay.
Oh yeah, you're laughing because yeah, guess what? I had differential geometry in college.
Did you?
I just told you I did. Why would you ask me if I did?
You did not take college, bud.
Honk honk. Yeah, here you are losing to a whole bunch of flat earthers in Discord.
No, you can't agree
Yeah,
with what
so
I
guess
said.
what? Yeah, guess what? I never went to a single college course in my life, and you're
No, you
getting
didn't.
embarrassed by a bunch of flurfs on Discord.
He can't agree with what I said, or else he knows the images that he posted in the
I
side
agree
channel
that it
are-
looks flat. I agree that it looks
I
flat,
don't
knowledge.
care if it looks
Let's start
flat.
there.
Yes, the ground looks flat, but if you scale it out,
All right,
like,
it
if you
looks
go
flat.
towards,
Great.
like,
Okay,
go
so you
If you
have a
scale
coping
it up,
session for
okay,
why.
so if you see something that looks flat and you scale it up, it's going to curve?
You can see the curvature. Yes.
So you just told
Yeah,
the
how do
entire
we do
room
that?
that it looks flat, and you say scaling it up
Who cares,
will
idiot?
make you
Be
see
quiet.
curve, even though you see the curve. Knowledge, you come around here all the time. You just made a new account.
No,
You're
I
actually a
don't.
clown.
No, you're the clown.
Well, then you have twins with the same voice as you, bro. Just a copy and paste.
So knowledge, this
fucking-
is what you can do. This is what you can do with this observation. You can
Don't care.
calculate.
You're not doing
What-
any
what-
calculations. You just
You
showed
could
me like
you
a
can
Google map.
calculate how much the refraction coefficient would have to be to have no hidden height on a globe over this
How
lake.
are you going to do
Do you know what
that
the
if you didn't
You-
take the air temperature into account? Tell me.
No, you can
is not-
calculate. Listen,
Wait, did
listen.
you do
You
it?
can
Did you do it?
no.
Did you do it?
Listen.
Did you calculate
Listen.
the air pressure, the air temperature?
No,
or
because
the-
I'm not the one making the claim here.
Then your image is wrong, buddy.
No, what's wrong about the image?
Did I? Because you didn't calculate the air temperature. Because
Right. So how does
the light
that
rays
make the
bend
image
downward.
wrong? Right. So you're saying that refraction. You're saying that you can have a refraction coefficient of about k equals 0.99 with no miraging effects or anything. You probably don't know what I'm even saying right now, do you?
Well, he
know
said
what a
you
refraction-
calculate air temperature. I want to know how you calculate air temperature. Yeah, go describe a calculation of air temperature, because you know what? I think you mean measurement, but you said calculation instead. So how do you calculate air temperature?
Would you agree that cold air is dense and warm air is dense?
Yeah,
right?
so how do you calculate air temperature?
Would you say that light travels slower in dense air? and
Yeah, yeah.
faster
So
in
how do you
cold?
calculate air temperature?
So
The
if
answer is
you
yes. How do you calculate it?
So if you don't do this in your images, right? If you don't understand how the light travels slower,
I understand.
it's
I
going- the
completely
distance
understand
is
it, okay?
going to
Probably
be
better than you. How
wrong.
do you calculate it?
The distance is going to be wrong.
So just keep dodging the question because you probably effed up and you don't want anybody to know. How do you
The
calculate air
distance.
temperature?
He just said the distance is going to be wrong.
Oh, God.
The distance.
Yes, because the light travels slower like compared to like what the temperature is.
So what distance is going to be wrong based on that?
Yes, what you posted.
What distance? The distance of what?
Let me go
The
get
distance of what?
You said
Can't you
that this
answer
was
the question?
21 feet, like 2.7 point like horizon, like what you posted here.
That's
right?
the geometric horizon
Did
distance.
you
That's the
calculate
physical.
the temperature when you took this? Did you do it?
No,
Why not?
because I'm not making a
If the distance
claim
is
to the
going to
shape
be
of the
real,
Earth.
if you
You are.
understand how refraction works, you have to calculate the temperature to actually understand what
I'm
the
not
distance
claim.
is.
Okay, all
Yes,
right.
you
So we
are.
can.
Yes, you
No,
are.
I'm not. I'm not trying to claim the shape of the Earth. You are. I'm just
No,
testing that,
you're
and there's
trying
no
to tell me
curvature.
that you posted inside
Calculate
there.
temperature.
Let me go get it for you. What you posted.
No, I already know what I
You showed
posted.
me a Google image of a distance of, what was it, 21 miles? How do you know it's 21
Yep.
miles if you didn't calculate the temperature?
According to the globe, right? According to the maps of the globe,
okay,
it's 21 miles, right?
But
So according to the globe model, over 21 miles, you should have 294 foot of curvature. Okay, according to the globe model, refraction coefficient of 0.13 is standard refraction. Right? Applying all of these things, the shoreline on the distant, right, 21 miles away should be around 200 foot hidden. It's not. There's actually no horizon over the entire 21 mile
air
lake.
temperature, though.
Oh yeah, I forgot to calculate
Doesn't
that.
matter.
Let me just get my calculator out
So the
and calculate
200
it right
plus
now.
feet is now null and void.
Yeah, it can't be 21 miles anymore because I didn't calculate the air temperature.
Any picture that you ever take, it has to come with a calculated air temperature now.
If you want to calculate the distance, yeah, it has to be that way.
I didn't calculate the distance. I just checked Google Maps.
Google Maps is lying, though.
Yeah, well, they didn't have a temperature calculation, actually, now come to think of it.
Did they get a
So I guess,
temperature circumference as well? A pressure temperature circumference?
You should
maybe?
calculate the CO2 and the humidity. Calculate the humidity and apply those, and then maybe it won't be 21 miles anymore across that lake. Maybe it'll be 50 miles.
The Earth is actually getting bigger and smaller based on the air that surrounds it.
Well, based on this observation, you would have to have a radius of like 1 million miles or something like that. So knowledge for this observation to be correct, you would have to have a refraction coefficient, right, which is little k equals 0.99. There's no evidence that such a refraction coefficient has ever been measured using visible light of any wavelength especially without crazy destruction like miraging effects, Fata Morgana, Superior Mirage, that kind of thing. We don't see any of that. In fact, it looks nice and clean and clear. So for you to claim that there's some type of temperature, pressure, humidity relationship that could cause 294 foot of curvature to just be completely flat is just a bullshit, baseless claim that you don't have any evidence for to back up whatsoever. And that's why when you bring up refraction, you globers, you shoot yourself in the head.
No,
it's the worst nightmare. It's your worst nightmare. Because you don't have a single observation throughout all of history that accurately measured the temperature gradient vertically between point A and point B, and then used those measurements to do a calculation to work out the refractive index along the path, and then use that, right, to deduct the refraction on the particular day back to it matching the globe. You don't have that. It doesn't exist. All you know how to do is just say the word refraction. You learn how to make a noise with your mouth. Congratulations.
But you're
have another
absolutely
bong
wrong
hit.
about this.
Oh, really? What was I wrong about? Name one thing.
Everything you just said.
Name one thing.
Yeah. Like,
Name one thing.
yeah. Like, right, you said that, like it should be hidden, like, right?
Like?
Physically hidden, geometrically hidden, physically obstructed behind the curvature of the Earth. Yes. 223 feet.
Okay. Prove it.
Okay. Right. So if the Earth is a globe with a radius of 3,959 miles, we can use the equation 1.225 times the square root of the observer's height in feet, which will calculate the distance to the geometric horizon, which is 2.73 miles. Right. And then we can calculate that the hidden height for the distant shoreline, 21.03 miles away, is 223 feet. If the Earth's a globe. Is the math wrong? Do you think the math's wrong?
No,
it's funny how they would make an Earth curve calculator, but when you go to use it, it's always wrong every time. No matter where you are, no matter what the fucking temperature is. It's funny how it's always wrong every time, anywhere, any distance. But you, day one, learning about flat Earth, you wouldn't know that.
No, like.
No? Like? Good response, bro.
Yeah.
Is that it? You done? Knowledge?
I don't think he has experience talking to 24/7.
He doesn't have the knowledge.
We can present not only laser measurements, but long distance, high altitude infrared photogrammetry, microwave-link tests, all kinds of things.
No, you can't. You actually distort everything.
We can and we do.
No, you don't. That's
why it's posted all over our home server as well as YouTube channels and everywhere
and no
else.
one takes you seriously.
Well, that's your problem, okay?
And everybody laughs at you, even scientists. Even
scientists, right? Yeah, even those scientists that are on our staff, because we're paid to indoctrinate you.
I wouldn't say that they're paid. I would just say that they're wrong.
I'm joking.
Like, I don't
it's
think
a labor of love, man. Nobody comes to this conclusion with any payment in hand.
I don't think you have any bad intentions.
You know why people don't take this seriously? It's because they've been told their entire lives that this is not a topic to be taken seriously. Totally serious.
I don't do it as a pilot because I need, like, there to be a globe in order to navigate. Because
I know. You need your coordinate reference system to be a globe, to be interoperable with everybody else that uses the same coordinate reference system.
No, I know that time is fourth dimensional, meaning that space-time, so that would mean that, like, the differential manifold, like, affects the metric tenth. That's what creates the geodesic. The geodesic is the shortest path between 2 points, like, on, like, a curved surface. That's what all pilots use to navigate. All of our airline routes, we use that to navigate, like, from point A to point B.
What type of pilot are you? I didn't know.
It's relativity that causes it to look straight when it's not. Great. So how would you know it's curving if not for relativity?
How do you know it's curving?
Yeah, if not for relativity, because you brought up that space-time, right, affects the metric tensor, which allows for geodesics to be the straightest path in this version of space-time. So are you throwing Eratosthenes under the bus and all the Greeks, Aristotle, Epicurus, and so on and so forth?
Aristotle? He's a philosopher. Come on, boy.
Yeah.
See, he doesn't even understand the point you're making.
No, he doesn't.
We even throw Newton under the bus because his theory is wrong, right? About gravity. Gravity isn't a force.
I mean, if you accept relativity, you wouldn't say that, though. You would say that Newton's laws are actually part of the entire general relativity framework.
They're also part of our modern way of life.
All right, so now you're not throwing him under the bus.
I'm throwing Newton under the bus, not Einstein.
Yeah, but Newton's laws are part of relativity, right?
No, I'm talking about his theory of gravity as well.
Okay, good. So I can agree there. So nobody knew that Earth was a globe until what? Einstein? Is that what you're saying?
We knew the Earth was a globe, I think, before Galileo. Like, we had Bruno, which, like, he was executed for that. That was pretty funny.
Oh yeah, how would you know that if space-time itself is curved and you can't measure it?
We can measure it.
Then how did they measure it if the objects in space-time they were using were also curved and look straight?
Because we know that time is relative to the observer. That's how you measure it.
How did they know that back in the 1500s?
I'm talking about Einstein. Moment.
I know you are, and I'm asking you, how did they know Earth was a globe before Einstein?
How did they know? Because of their observations, like, right?
Right, but hold on, but you said the observations are limited to the manifold of space-time through which they're observing, which means their observations would make it look straight, even though they're not. So how did they know that before Einstein?
You tell me.
That's your claim. I'm asking you how.
I was saying, like, the Romans knew this. Galileo knew it. Bruno knew it.
Yeah, how? If they didn't have any concept of four-dimensional manifold space-time, how did they know?
Because they observed, like, the planets and like the moon, which is like,
Like,
if those are spheres, there's no reason not to believe the Earth is a sphere.
Okay, so guess what? If you're in a parking lot and you look at cars all around you, do you think you're a car too?
no, but the parking lot is. The parking lot's actually a car.
I know that when I take off from, like,
Wow, these guys are falling apart.
I mean, you would think it'd be some complicated like thing that they were doing, but then he just says, "Oh, we look at moon. Earth must be like moon." Like, bro.
Do you use
Like, $1 million terms like relativity and manifolds, and I don't think he understands where he's getting into with all this.
So we say that, like, time is relative to the observer, right? Meaning that, like, with a strong, like, gravitational, like, pull, like, we know that time ticks, like, slower on the surface of the Earth near the equator, simply because, like, it's near, like, the center. We know that it ticks faster up in the air, right? So how does that translate to modern life? Well, GPS satellite systems. You have to take time dilation into account. Yeah, the GPS
I'm glad you brought this up.
Because because time dilation is proof that Einstein is correct. We use them. Do you use them?
I love GPS systems. Yeah, let's stay on GPS for a while.
How are the clocks accurate if you don't take time dilation into account?
How would you know that? Let me tell you what. There's one of the guys who owns a bunch of patents on the GPS system. His name is Ron Hatch. He's got like maybe 20 or so patents on this, and he speaks at forums involving geodetic surveying and space physics, all kinds of things. And you know what he said? As one of the inventors of GPS, he said that general relativity corrections are actually canceled out by special relativity. Which means you don't actually need to take them into account. That's right. And that's how he fixed the GPS network. No, that's how he fixed it. And I'll tell you how he did it. And his explanation was based off of the idea that because Earth, a globe Earth, right, has a bulge, an equatorial bulge of about 14 miles, that the increased mass in a general relativistic sense counteracts the motion, the relative motion of the satellites above the Earth in the ECI frame, Earth-centered inertial frame, due to special relativity, and that the precise cancellation of effects means that the entire general relativity correction is not actually needed whatsoever, and is actually canceled out elsewhere within the system.
No, it isn't.
No. Would you like to read a book about this, or maybe his
I don't
papers?
care
I can
about the
post a
book.
bunch.
I understand that they would be a lot slower, or they would be inaccurate.
Oh, a lot. How much slower? How much
It
slower?
would be like 38 like microseconds, right? Because like
per year.
Because like it's the exact time it takes like for like a light signal like to travel.
Per year or
like,
per day?
It would be 10 like kilometers.
How do you know the clocks run slower? in an accelerated frame.
How do I know? Because you can test it yourself.
Yeah, how is that done? What's one of the best
Why don't
tests?
you do it? Why don't you do
No,
it?
I'm asking you. This is your claim. I want you to describe for the audience how you know this is true.
Because space-time is distorted. Okay,
I know
time.
that that's the claim. You keep repeating the
It's
claim. I
not
want
the
you to know.
claim. It's what's actually true, buddy. Did you go to college? Like
How
you
do
claim?
you know it's true? Do you understand what I'm even asking?
Because I fly the plane, buddy.
Oh, whoa. So your plane has like an atomic clock in it?
Like geodesics exist out of space-time. Okay?
They exist in your conceptual math, in your
No.
spherical coordinate system.
Like the geodesic is what we all pilots use to navigate. Like it's called, like all airlines do this.
I understand. Yes. Would you like to discuss the Air Data Inertial Reference Unit of commercial airlines?
What is a geodesic? Can you explain what a geodesic is?
Yeah, it's an arcing path within a curving reference frame.
It's a straight line on a curved surface.
I said it's an arcing path within a curving reference
In order
frame.
for us to follow a geodesic, we're following a curved surface, meaning that the Earth is round, buddy. Are you saying that every single pilot in all the airlines are wrong and you're right?
No, I'm not. I'm
basically,
actually asking
the
you if
Earth
you
is a
understand that a
globe
curved
based on
path within a curving
terminology
space-time.
and not anything to prove.
No, they say they fly over a flat Earth.
Yeah, and second off, do you understand that the airplane has one job to do? If you fly with a modern aircraft that is taking elevation and azimuthal headings, it has one job to do, and that's plot your time over distance within a geodesic coordinate system.
And that's the shortest path between 2 points?
How do you know that is in reality?
Because it's a straight line. All straight.
In reality, yes, it is. Congratulations.
Two-dimensional manifold, which is the flat plane. Like the shortest path between 2 points is a straight line. You would do that, like so.
So not over a ball then. So not around a ball then.
Exactly.
Yeah, so not around a
destroyed his
ball.
own argument.
A straight line
Yeah.
in like
It's
when
not
you
around the
fly
ball. A straight line does not curve.
is a geodesic.
No,
which is
a straight line does not curve.
But you follow a curved surface. That's the straight line when you fly.
You're like what do you call that? Jesus, the walking, talking contradiction. A curved line is straight.
Straight lines work differently.
Right. So
straight lines are curved. Curved lines are straight.
His coordinate
triangles are
reference system is
curved.
perfect.
Triangles are straight.
So
his frame of reference is one that is curved. Okay.
Are they all wrong? You're right. We don't need geodesics anymore.
What do you mean they're all wrong?
All airline routes by commercial use are navigated for the shortest possible distance, right? To maximize our.
How do you know that's true? I'm going to say BS. Okay. How do you prove that?
Okay. Hold on.
Dude, why does it sound like you're talking across the hall?
Listen, you have a curving frame of reference, and your paths are also curved within that frame of reference. The question is why, when you're taking straight paths in reality, as you admitted.
Yeah, it's a tough spot.
My fear of flying's even more justified now after listening to this guy. Shush.
Dude, and chat is going crazy. It's like a 2-for-1 in here. You can knock them down on both sides. The guy in chat's having a meltdown. He doesn't know what a triangle is. I had to tell him. He said, "You didn't have to tell me what a triangle was." I had to clip it for him where he said, "Okay, professor, what is a triangle?" Because he had to ask me. I said, "You didn't even know what a triangle was."
It's kind of like when they do the Michelson-Morley test, right? And they did not detect that Earth moves within its with respect to a fixed reference frame. And they say, well, the reason why we couldn't detect that motion is because what we're using to measure it with is being compressed due to space-time geodesics. And then, so how do you prove the unfalsifiable? You can't. So it's just a coping mechanism. until other data comes to light. And I'm surprised he never brought up any of the relativistic experiments, or I should say tests, that have been conducted. Like Heffel-Keating or the Pound-Rebko test or anything like that. He does not know a single thing about any of this that's been done within his own framework of knowledge.
Yeah, well, he's posted in the side chat his confirmation of the Great Circle line shortest flight path, right? It's just presupposing a globe. Once again, Yoda's asking you to validate that it's actually a straight line, and
use this to navigate. All commercial airlines do
Yeah,
this.
we understand that they do. We understand that the map they use has 2 points of origin.
Wrong,
the map they use has 2 points of origin, one in the north and one in the south, connected by longitudinal meridians. We understand that. That is the map. The map is not the territory. You're making the error for all the ages. You're putting the map before the land instead of the land before the map.
Do you understand what a Great Circle route is?
Yes, I do. And I understand for that to work, you need to have curvature in the vertical axis, which could be the z axis in this convention.
So does airplanes take off and get from point A to point B all the time? Right?
Oh, so now you're asking me to accept a pragmatic fallacy?
In
You're
order for
asking
you to
me
prove
because
that
it
it's
works,
wrong,
it must be
you have
true?
to prove that we don't make it to our destination when we do.
No, I don't. No, I don't. You have to prove that what you're doing is what you say you're doing. So how would you prove that you're curving in the vertical axis?
How would you prove it?
Do I have to ask the same question that you asked? Yes. How do you prove it?
That's easy. Like you would know, we've already proved it, like through Einstein, right? We know that time is fourth dimensional. Fourth dimensional means that like gravity is an effect of time, which means that like, so when you like, so space-time is warped, like due to like, the mass, like, right? That's what creates like the curvature. That's what gravity
Yeah, how do you
is.
measure the warping? How do you measure that?
How do you measure it? By putting like, well, you could just, by the object, like that warps it.
Yeah, how do you measure that? You keep repeating the claim. How do you do that?
You tell me. He
No,
doesn't know
how
how to
does the
measure
object
anything,
warp
dude.
space
He
knowledge? How do
calculates.
objects warp space-time knowledge?
They do because of their mass, the objects.
How do you know that's true?
How do I know it's true? Because the geodesic is born out of it, and I navigate it.
How do you know the geodesic is true?
Because I get from point A to point B every day.
So what? Guess what? I have a GPS and it takes me the wrong route to my friend's house, but it thinks it's the shortest route.
Well, sucks.
Do you understand you're not verifying the thing in question, right?
Right. You keep repeating the claim as evidence for the claim knowledge, and that's not how this works.
But
That's not how you prove something.
Experiment. I can prove that time ticks slower on the ground than it does up in the air. You can do this too.
Good. Okay. Present me one example where that's true.
I posted it in the side chat, but like this chat like deletes all of the messages like after a day or so.
Okay, why don't you describe for the audience what that was?
So they did an experiment about like the clocks, like where they put like the clocks on the ground, and like they observed that like the further away you are from like the Earth's gravitational pull, like towards the center, like time ticks faster in the air than it does on the ground. Hold on,
okay, so what did they do?
Let me go get it. I'll post in the side chat just like I did the other one.
All right. Not that I want to poison the well, but you're going to post the Heffel-Keating test, which was refuted by James Kelly in 2002 Scientific American when he found some unpublished data regarding this that they'd thrown out because they had actually flown the atomic clocks on 747s east and west that had actually, through their flights, had logged time that ticked in the opposite direction than what was supposed from special relativity. And I can post that information, but I'll let you post, and then you can describe for the audience what I just said to the audience. How about that?
Well, I mean, if there's a second, I'd like to point out that even the claim that the airplanes fly the shortest route, which is by definition a straight line, is analytically false on his paradigm where the airplane is in the air in free space. So his claim would have to be that the airplanes are not flying the shortest.
They are.
Well, no, I don't mean to sidetrack you. Go ahead with your paper.
The only time
Are you a
that
commercial
they would
pilot?
be doing that
Knowledge?
would be
Just
for,
quickly.
like, the only
Just a
time
quick
that they would be
question.
doing that would be towards commercial. But the only time that wouldn't happen is for safety reasons, right? Like, right, on perfect day, perfect conditions, you would follow the given. But
No,
like,
I'm pointing
but
out that it's just analytically false. It would just be that they're in free space. The shortest distance between 2 points is a straight line. You're saying that they're following the surface beneath them in the air, right? So that wouldn't be the shortest distance between 2 points in the air, analytically false.
the geodesic is. Yes.
Are you a commercial pilot?
So,
Knowledge?
so
Knowledge.
Dr.
Hello.
Yoder, okay, so in
Knowledge.
these should not be like
Knowledge. Can you hear me?
differences at all. Be quiet. No one cares.
Answer the question.
No.
That's a no. I'll answer for him. No, he's not. Drone
Stop asking me
licenses, like I told you the other day, flying a drone in your backyard does not make you a pilot.
Yeah, what type of pilot are you?
I told you.
No, you didn't tell me. That's why I'm asking.
What type of license?
I'm
What type of
answering
license
his
do you have?
question. Stop asking me a million questions.
Just asking you one question.
Go ahead.
Well, I just want to get this one answer, right? What type of pilot? What type of planes do you fly?
What type of license do you have, more specifically? See,
Should be an easy question to answer.
If you can't answer it right away like that, then we don't believe you.
Hey, Knowledge, how come in the test results from this that were dug up by James Kelly in 2000, 2002, test results show both positive and negative numbers for eastward and westward flights with respect to the fixed atomic clocks on the ground?
The 2002 what?
Hafel-Keating, okay? Your claim was that the Hafel-Keating test had proven general relativity, but when we pull up the actual data, which I posted at 13 minutes past the hour, the test results for eastward are positive and negative with respect to a stationary ground clock. And the test results for westward were positive and negative with respect to a stationary ground clock. Why would that be the case?
There shouldn't be any differences. It's because of like the gravitational pull, right?
Well,
like,
why would it be positive and negative? Because it looks like the plane was flying eastward and westward with respect to only an eastward direction. And for westward, it looks like it was also flying eastward and westward with also respect to a westward direction because the clocks were positive and negative.
Yeah, so what's your point?
The point is Hafel-Keating is actually considered fraud.
This isn't fraud.
The thing that you think proves that special relativity is true is considered scientific fraud. Yeah, it's considered for the reason that I just said. Yes,
there shouldn't
because
be any differences between the clocks. Okay,
there was differences. Okay, the differences were not only differences, but positive and negative differences, which means the claim direction
your claim is
within the frame of reference is going to be eastward and westward with respect to eastward, as well as eastward and westward with respect to westward.
Okay, but time dilation says, like, right, that like when you're near a strong gravitational pull, which like when you're on the ground, time is going to tick slower because gravity, like, slows down time. Okay, that's the reason for the differences. When you're up in the air, that's the reason why you get the difference in the fucking different times here, right?
So why would the clocks tick in the opposite direction? Because what, gravity? So you're saying you can't falsify this? You're saying that you can't tell the direction the airplanes were flying in special relativity because of this? Great. Back to the drawing board for you.
This isn't fraud. You're just an idiot. This is exactly how we. This is how we update our GPS.
So it's his
system,
fault.
right?
It's his fault. You're an idiot, right? It's
Yeah,
somebody
sounds
else's
like
fault. You're the idiot.
Is that what you say? Like an experiment that proves Einstein's theory? You say it's fraud?
No, it didn't. I'm telling you,
Einstein was
it didn't match the
85
predictions.
IQ. Yeah, Einstein was 85 IQ. He walked around with his tongue sticking out. Did you ever see that? And he wore women's shoes.
You know, the scientific community fully accepts this, right? They didn't call it fraud.
No, they don't.
I know they accept it, but they don't accept the James Kelly investigation that was done years later, because this test was done in the 70s. This test was done in the 1970s, and then republished in the 1990s and 2000s.
Can you post that
2000 by Scientific American. Huh?
Do me a favor and post it. I have not seen it.
I just posted the data. You want to see the rest of it?
Yes. You could be right. I don't know. I got an open mind here.
Doesn't sound like it, but okay. Go find it.
If the math is correct, I can't argue with it. I'm sorry. I'm afraid.
Yeah. You know how to do math for relativity?
I did it for the neutrinos earlier.
You did trigonometry. You didn't do any math regarding, because you know how they detect neutrinos? Do you know why they use a Monte Carlo simulation? Do you know why they use a Monte Carlo simulation to detect neutrinos?
Wait, you were the guy I was talking to.
Duh. Yeah, why do they use Monte Carlo to detect neutrinos?
Why do they?
I'm calling him James Kelly. It's A.G. Kelly. All right, here's the paper.
I want to see it.
Okay, here it comes.
I'm dealing with a flat earther always has to be wrong guy in chat. It's funny. So now that shark fin's an irregular shape, but triangle B is a concave triangle. He called it, but the shark is not a triangle anymore. But space B on this chart here, this is a special triangle. He said it's got its own classification, and then I posted this, which is the shark fin swimming the other direction. And he said, no, that's not. So I'm not sure how shark fins work with globers anymore.
I'm sorry, so?
Okay, I'm going to read this for the audience. In Heffel-Keating test, did they prove anything? Question mark. There's a case for potential fraud when the raw data from the experiment showed much larger variations and inconsistencies than reported. When he examined the raw data, which was not only originally offered with the 1992 Science paper, critic A.G. Kelly, not James Kelly, so A.G. Kelly, discovered that the total range of drift during the experiment was about 7,000 nanoseconds, which is significantly larger than the reported effects. What's worse is the data appear to have been altered in order to falsely predict, really post-dict Einstein's relativity. According to Kelly's table, the alterations were significant. Clock 120, original reading was negative 57, altered to negative 55. Clock 361 eastward, originally reading positive 277, altered to negative 51. Clock 408 westward, original reading negative 54, altered to positive 262. What was concluded by A.G. Kelly and other researchers is that the atomic clocks were not stable. The original data tables were altered, and there's evidence of intent to deceive by data fitting the results to fit Einstein's equations. Here's some of the data that A.G. Kelly examined, which he presented for the first time after Heffel-Keating withheld it. Yeah, and I get that many scientists, people who claim or profess to be as such, refer to this test as definitive proof of special relativity. I'm also aware of the criticism behind it. And you know what? As somebody who's academically honest, I think it's important to weigh the evidence, positive and negative, against claims, don't you? Well, I guess we're done here. I will yield the floor to everyone else. Sorry for hogging it.
No, that was a good addition to this beautiful clip. But I want to know if this guy's really a pilot or not. Still, he won't answer. So if he
I
won't
talked to
answer
him
that,
yesterday. I told him drone pilots don't count, and he would never respond. So we know what he is now.
maybe he's a flight simulator pilot.
Yeah, Microsoft. We included that one too. Remember? We said, and there's another game that one also does not count as being a pilot, dude. Even though you earned your license in the game, it still doesn't count.
Yeah, Pilot Wings on Super Nintendo.
Yeah, Atari Chopper Attack.
Ace Combat 7. It's like Call of Duty for wannabe airline pilots.
So we're going to learn about triangles because Strudel at first knew what a triangle was. Then I showed him another picture. Then he said, well, no, there's different triangles then. All of a sudden there was different kinds of triangles. Then I showed him shark fins. We went to shark fins. He said, not a triangle. Showed him shark fin triangle. But showed him a shark fin with one curved side, or that is a triangle with one curved side. You show him a shark fin that's a triangle with no curved sides, but he said that's no longer a triangle. So these guys are losing their minds. I'm afraid that I might have to retire this test because I don't know what to do with it anymore.
Strudel, sounds like you got a bit
Yo,
wrecked in the
how's
side
it
chat.
going? Whatever you say, baby girl. What are you saying, boys? What's
You broke him.
crack-a-lacking? How are we
You
doing?
broke this one good and proper.
I'm so broke. Ooh.
Now I can see why you're on mute.
No, this is how I talk normally, baby. Right, so
yeah,
what's
he sounds
going
like he's on
what
drugs.
Are we talking about?
Brainworms.
Drugs. Hey. You got some?
He's embarrassed. That's what it sounds like when they're embarrassed. Don't be embarrassed, dude. Every single Glober fails it.
Dude.
Every Glober fails it, dude.
Oh, what will I do? So yes, like I said, there are standardized triangles and they are flat-sided shapes.
No, they're
3 points. Yes.
So 3 angles. 3 points is not an angle.
Triangles. There are triangles with extra classifiers.
Like if I put two oranges next to each other and they meet at an angle.
There
if I
are
put
triangles with extra classifiers.
No, there's not extra classifiers.
Yes,
what?
They are. They are not
like
purely triangles. They are different shapes, but they are called triangles. Yes.
No, triangles have 3 angles.
They are referred to as triangles. Yes, they are referred to as convex and concave triangles. The word triangle is there.
So there's 3 angles in them?
You are correct. You are correct. Triangles, specifically just the word triangle, only have 3 sides and, 3 interior angles and 3 points. Yes, you're right, and they add up to 180 degrees, which is what I'm trying to explain to you.
Is a shark fin concave or convex? Hey, Strudel, is a shark fin concave or convex?
It has, the one he sent me has 1 concave angle, 1 convex angle, and 2 bottom angles that have they're actually convex. Yeah. So that's actually a 7-sided shape he sent me. The one that he asked me about.
Holy shit, a 7-sided triangle?
It's not a triangle, no. Yeah, you're right.
It's not even a triangle?
I said it wasn't.
See what happens when you ask him what a triangle is? He came up with
Dude,
an
look at the
hour.
image you
An
sent
hour
me.
now. He's been trying to
No,
figure out what
hold
a
up.
triangle is.
Look at the image you sent me. The image you sent me has waves that make up the bottom side, which is like
You
should
have
six
said
different
no.
sides.
That's a
Actually,
shark
I did
fin.
say no. I did say
Yeah,
no.
you should have said it's a shark fin.
There's a shark fin and waves actually.
Just say it's a
made
shark
up.
fin.
No, but
It's a
it's a shark
cartoon
fin
drawing
with
of a
waves.
shark fin. That's all
Yeah,
you
but
had
the
to say.
2D shape.
See how you
The
didn't pass the
2D
psychological
shape
test I
is
was doing
1,
on you?
2.
This
The
is just a
2D shape.
psychological test I do on
The
you guys.
2D shape is 1, 2,
What the
3,
fuck?
4, 5, 6.
What
It
is
has
a
6
lightning rod,
angles. The
dude?
2D shape you sent
What
has
the
6
fuck?
angles.
They're fighting all the time. Fighting.
It's not a pure
All
shark
because I
fin.
asked him if he knew what a triangle was.
Yeah, and you were wrong. I was right. Yeah,
Strudel.
exactly.
Strudel, let's see if you're right. So a triangle
Oh my
is
god. A
it's got three
triangle
angles,
is
right?
a three-sided shape with 3 angles, yes. 2 angles
Okay,
at
great. So
120
let's
degrees, yes.
test.
But there
Anything
are
that
Well, it looks
doesn't
like we
have
gotta find out what an
classifiers
angle
of
is.
triangles. But there are
Yeah, that's what we got to do. Okay, it's better if you're not talking, Strudel. I think even your folks would agree. So let's just do the final test. Can you get me the angles, all 3 angles, inside that triangle, and we'll see if you're correct. The thing that you think is a triangle, like the shark fin. Let's see if it's a triangle. Get the angles, and we'll see if you're right.
Thirty.
What? Dude, I never said it was just purely a triangle. I said it was a concave, convex triangle, my dude.
Are you
Go
just
on, look
making
what
stuff
that is.
up?
But my
No, was that
dude,
made up?
all I
Google what
asked you
one is.
was,
It's
what's
a
a
real shape.
triangle?
It's
All I
what do you
asked you was,
mean?
what's a
Yeah, but you asked me
triangle,
what a shark
Strudel?
fin was, and I told you what a shark fin was too.
And I said, is
What
this
are
a
you
triangle? And you
saying?
should have said, no, it's a shark
I
fin.
did say it. I did say no. You're reinventing history in real time. That's crazy.
You said it's a 7-pointed object.
Yeah, the one you sent was, because it has waves at the bottom of it which make up the rest of the shape. Yes, you're right.
Are those points angles?
Yes! What the fuck is he saying?
Whoa.
What
So
are
we
you
can add up
saying?
the interior of that, right? We can measure the angles on that shark fin.
It'll be much greater than 180, yeah, because it has
The
many
angle,
different
every
shapes.
angle.
And it's
The magnitude
concave.
of every angle is
How do you make a curved angle? Define an angle, please. Yeah, what's an angle?
This is crazy, dude. Yeah, it's point, bro.
I broke you,
Oh
didn't
my
I?
god.
I'm sorry,
No, I'm
everybody.
laughing at you. It's hilarious. What you're
I
saying
asked
is
you what an
fucking
angle
funny.
was. What's an angle?
Define angle
What do
or
you
go
mean,
back on
what is
mute,
an
Strudel.
angle?
You're painful
What
to
do you
listen to.
mean, what is an angle? Do
Just
you not
define it or
know?
go on mute. You have 2 options. Which option do you choose? Define angle or
Measure
go on
with a
mute?
protractor, my guy. What do
Define
you
angle or go
mean?
on mute. Last chance. Okay. You made that decision.
Holy crap. I haven't done that in a long time.
Yeah, stop hurting these
Right.
globers, Professor, bro. It's
Yeah,
not
no
fair.
side
It's like
chat
beating up on a
privileges.
kindergartner. Maybe you need a preschool test triangles, or do they even have triangles in preschool?
Yeah, the Peppa Pig. We need to show them the Peppa Pig series of shapes.
Oh,
Running
so you
shapes
gotta
with
make
Peppa Pig.
you gotta make the triangle into Peppa Pig, and then maybe they'll get it. Okay.
I literally have a meme that does that. It points to Peppa Pig's mouth and says, "Is this a triangle?"
Oh shit, it's already been done. Oh my gosh! All right,
Yeah.
we're cooked. couldn't sleep this morning, so I just went on TikTok and see what was going on, and I finally saw that Angels of Light guy. It's like the one guy I haven't seen on there. I gave him a follow, and within like 5 minutes of him starting his live, he had like 200 people in his chat, and like yeah, I'm like, who is this guy? I had no idea. And I went to his channel, and I didn't know he was like one of the bigger, or the biggest TikTok flat earther out there. 65,000 followers, and yeah, his style is a bit interesting. I wasn't a big fan of it because he kind of, the Globers would ask him one question. They'd be like, okay, so what about like, I don't know, like the sun or something like that. And then he wouldn't talk about the sun. He would shift it to a different topic. So he would shift it to like airplanes, right? So
He likes talking about airplanes. Yeah.
yeah. So I don't know. It wasn't for me per se because like just address what the Glober is saying and like don't just like
So if I
run
told
away.
you the sun goes away and that's why it looks like it's going down around the ball, have you ever seen a plane fly away from you? What would you say?
Have I ever
You would
seen a
say,
plane?
"Oh, you would say, oh, now I get it. Gee, I shouldn't have said anything."
Yeah, but as the Glober, right? You're clearly not going to think like that. So you
No.
kind of.
What happens when you okay, Glober, because I can tell you still are. What happens when you see a plane flying away from you? What does the plane look like it's doing?
Yeah, it's just going out of your vision, clearly. But
It
they're not
doesn't
going to
look
say
like it's
that.
going down. It does not now. It doesn't look like it's going down.
I get where you're coming from. I get what you're saying. But to just like address the point, besides, because every time a Glober brought
I
up a
did.
point,
You see that? How I addressed the point? I'm sure he does something like that too.
yeah,
Yeah, some of his arguments are good. A lot of them are just like David Weiss scripts. But he does a good job overall. I think it's difficult to sit there and debate Glober after Glober after Glober for hours straight every day.
yeah, I get it. I listened to him for like 15 minutes, and like every single question the Glober asked him, he went to a different like top. Like he went to his own like wheelhouse, right? He didn't want to address exactly what the Glober was saying, right?
Yeah, he does that a lot.
He needs to
And
hang
if
out
he
with
gets a
us a
bit
bit more.
stumped, he goes into like a script. He'll say one of the weak scripted answers and then like laugh and mock and ridicule until that person goes away. And he does the whole if it's not two mediums, there's no such thing as refraction thing as well, because I guess he heard certain flat earthers say that once upon a time.
He was
But I think
dumped
he
on
does a
by the
pretty good
FED
job.
crew, unfortunately. So he stopped hanging out over there. And then I think we were a bit harsh with him when he came here, and so he just kind of left and did his own thing.
Yeah, he does pretty decent on TikTok.
John
Yeah.
Luna, who used to hang out here, is good friends with him and was an entree into that. But I think we alienated him too. So
Yeah. Well, these
Yeah, no, I'm
guys
not
are
saying
all
anything he did was
clinging
like
onto
wrong.
the AE map. They're all clinging onto the AE map still. So
that's a
what can you
big
do?
point. Them and the Aether Cogdician people.
It was your list, actually.
Yeah, it was my
That scared
list.
some of these
Right.
people.
It was my list, and before that, it was the Dr. Heffron Celestial Theodolite review that I've done. Completely crapped over that, but you know what? They can have it as far as I'm concerned, because they're not one of us. Yeah, I mean, like, and today it's even more like it's evolved. Now it's like the dual pole whatever system by E1.
which is another projected globe. It's like, where's this going, guys? I mean, every time you bring up like Walter Bislin / Shane's, projection, you're bringing up globes. If you're bringing up the E1 dual pole system, you're bringing up a globe. If you're bringing up celestial theodolites, where Dr. Heffron himself claims parallel rays, you're bringing up a globe.
Yep. But I don't think that the globe side necessarily gets to to just own the way that we see the sky either, because on a flat Earth, I mean, we're still seeing the sky like this, imaginary. Well, no, it's not imaginary, but we're seeing this perspective view of the sky that makes it look like a big dome in the sky. And they've kind of taken that and turned it into a sphere and then inverted that sphere onto the ground. And then they say, oh, this is reality, guys. And it just looks flat because of refraction when you test it.
Yeah, good point.
Knowledge, you want to come back and talk GPS systems? I'm here.
Real quick, correct me if I'm wrong, but I thought the self-theo was basically showing the globe they're wrong by using their ways, right? So it was like not necessarily saying those things are true, but they have to be true for the globe to work. And then they were showing why it didn't add up when you look into it.
So here's the thing. Here's the thing about that. They did not have first off, they did not take a real world observation from on top of the mountain peak in Colorado. What they did was they used stellarium to simulate a real world observation, and then they compared that to a real world observation. And they concluded that the angle to a star at a very specific, precise point in time, down to the second, was the same for a ground observer as it was for a mountain peak observer almost 60 miles away.
But wouldn't that be a way to cut out the ability to claim refraction? Wouldn't that be the only way? Because it doesn't matter.
No. First off, the angle they claimed was the same between these two observers. But here's the problem with that. There's supposed to be 1 degree of angular change for 69 miles. What they presented was data, one of them synthetic from stellarium, one of them real, showing the same angle to a star, separated by almost 60 miles.
To my knowledge, they took that into account because, like, as the star gets closer to the horizon, right, the 1 degree per 69 miles kind of goes out the window, right?
It definitely goes out the window. So in both cases, observers observed the star at 2 degrees. Was it like 31 arc minutes? 2 degrees, 31 arc minutes. Let me give you an idea what that represents. That's like taking 2 fingers and holding them out at arm's length in front of you. Okay, you got your middle finger and index finger on your right arm, right hand, holding out in front of you. That's about maybe 3 or 4 degrees. That angular width is what they're working with.
That's the difference from what the globe claims, or what?
No. This is what they're working with. They measured a star only 2 degrees, 31 arc minutes up from the horizon. The problem is anything below about 15 degrees in angular height is subject to massive corrections due to the flattening effect that we observe on the horizon. call it refraction. I hate to call it that, but whatever, it's distortion. They're looking through the narrowest, most turbulent layer of air within that tiny 2-finger width away from your eye on the horizon. They're using elevation angles so low that all the manuals, surveying manuals, celestial navigation manuals, all say don't go below 15 degrees because you're going to get massive distortions.
Yeah.
But they're relying on observations within 3 degrees instead of 15 to 20. Second off, the second observation point in this was not a real observation. It was a synthetic one derived from stellarium. And what they do is they go into stellarium and they take the refraction checker on and off, and they toggle it on and off. They're doing this in place of a real world observation.
Yeah, but
well, hold on. If their conclusions are true, then it means there's no angular degree of inclination with respect to distance traveled over the Earth.
No angular degree of declination
or inclination with respect to distance traveled, because you had two people separated by almost 60 miles of distance with no angular change to the star at the same exact precise time.
Isn't the whole point that once it's occluded by the mountain, that refraction is no longer taken into account, because it doesn't matter that it's so low in the sky, because once it becomes occluded, then that all the effects of refraction are out. So it was directly at that time.
Yeah, so already we're accounting for that. Already, if there's supposed to be 1 degree of change per 69 miles of distance covered, absent of any refraction, then how come they have 0 degrees of angular change instead of 1 degree for almost 60 miles of distance covered?
My understanding, and it could be wrong, is because of exactly what I just said, right? They were trying to take refraction out of it, so they wouldn't have to account for that.
We've already taken refraction out of it.
They wouldn't have to account for the degree of angle change, because once it's occluded, that's the arc minute, right, and arc second that they take. Once that's occluded, the degree of angle change, it doesn't matter.
So they're throwing either hundreds and hundreds of years of astronomical observations under the bus. No, they're either throwing 2,000 plus years of astronomical observations under the bus, or their methodology is corrupt.
Yeah, I'm not disagreeing.
Absent of any refraction, there's going to be displacement of a star's position with respect to your position on Earth, flat or globe. They did not present that.
Do you agree that the Earth isn't flat?
Oh, hold on. When Dr. Heffron was confronted with this, he said, well, I believe there are parallel rays from astronomical sightings onto a flat surface. Well, if that's the case, then rest in peace parallax. It means you can't use stars to navigate.
I never heard him say that, and I would have to.
Great. I've got 2 clips of him saying that, and I can post them in the side chat.
I believe you. I just, and to my understanding, I don't have the understanding how that would ruin parallax for celestial navigation.
I'll tell you how. If you have parallel rays to everywhere on a flat surface, it means there's no angular change by Euclidean geometry, because all rays are parallel to each other with regards to a flat surface that intersects them. And if there's no angular change, there's no parallax. If there's no parallax, there's no distance that's able to be discerned from one position to another.
Did you hit him with that, and what was his response?
Yes, I did. So this team came to me before Dr. Heffron went public and asked me for my input. This was about 1.5 years ago, almost 2 years ago, actually. So about 1.5 years ago. I gave him this exact assessment and said, the consequences of what Dr. Heffron is claiming are parallel rays to a flat surface, which is incongruent with observation. And there are about 4 or 5 other points I presented too, which, I'm kind of covering here obliquely. They ignored me and went ahead with pushing Dr. Heffron out in front of the community along with his observations. So I responded with an academic paper that I wrote addressing his points, which they published, and then they moved the goalposts on with their rebuttal on their Aether Cosmology Obsidian page. And then I got a couple clips of Dr. Heffron talking to McToon, explaining that there have to be parallel rays to a flat surface for this to work, which is a complete contradiction to what we actually observe in real life.
Thank you. I'll have to look over the Obsidian page where you posted that academic paper and read their response.
I'll post my paper. I'll post my updated paper, which they didn't even publish because I produced another paper in response to their goalpost moving. Let me go find that.
But then they wouldn't even address that response to their response?
Look at bloody globes. There's no water on those desk things. It says liquid on it, dude. Where'd you get that from? I gotta see this. Can you send me the link? I want to buy one. I want to take it apart. Where's your sister sauce? You gonna answer me or not?
Sorry, hold on. I have to find it. Give me a few minutes. I'm on a new phone and got new directory structure.
Not
so
you.
hold on.
Another one down.
There's so many of you. You're also unbelievably stupid.
Wow.
Isn't it funny? People that, not all, but many people that come on their Xboxes and PlayStations are just brain rot morons.
Well,
I don't know, man. You're the one that believes
their
Earth is flat.
Xbox and PlayStation. They might even have space games. They're probably playing a space game. What's the chance?
Oh my
Dude, are you
God,
playing a
space is
space
mine.
game?
Oh my
Dude,
God,
are
I
you
haven't
playing a
seen it. They're just made up space
Dude,
so they
are
can
you
get
playing
money
a
from
space
us. Oh
game
my
right
God.
now? Are you playing a
Those
space
satellites
game?
aren't real. They made it up so they can get money
Are
from
you
us.
playing a space game right now?
Playing Roblox or some little kid game.
Ooh, is that what you like to do?
Those pedos. I mean,
Walk around.
PDFs.
You guys walking around holding hands?
He ran away.
Yeah, I was kind of new to the flat Earth awakening, and I had been playing Star Citizen, and I bought some ships on there. They weren't cheap, and it kind of, ruined my enjoyment for that game when I figured out
Yeah, see, Flat Earth
that's pretty
saved you
funny.
money.
The
Actually,
propaganda.
it saved you money, actually.
Yeah, and time.
It sure does that.
All right, Amphibious, I tagged you. I think this is it.
Thanks, brother. I have to hit the road right now. I got to make an appointment, but I'll definitely read that. I will bookmark it.
Okay, cool. I mean, I could read it for the audience too here while everybody's listening.
Yeah, would you
This
be
is the
able
draft.
to? Would you be able to just give a brief of like your first response, right? Your first academic paper, and then their response to it, because right, this is the third kind of iteration of this is the response to their response, right, to your first
Yeah,
academic
sure.
paper.
So basically, what they came up with initially that I responded to was something I called the Heffron Delta. The Heffron Delta was a scaling factor. It was basically the god of the gaps, a value that could be inserted that can scale independently whether or not Earth is flat or a globe, depending on the timing of occlusion of the star by a distant object. So I attacked this point and called it arbitrary. The arbitrary delta was empirically unsupported because it was a coping mechanism, and it revealed basically the weakness of their methodology. The second point that I'd argued was their misuse of stellarium, their reliance on a tool which was rooted in spherical geometry, which was misinterpreted as evidence for their side. And third was their neglect of recognizing actual atmospheric distortion, which they had initially blamed on the lenses of theodolites in the first place. That third point has since had the goalposts moved several times. And the Heffron Delta has also been updated. That's it. I mean, that's really all there was to it.
And then what was their response? When you say they updated Heffron Delta, what do you mean by that? What did they do?
They said that they no longer use that anymore. They said that they don't need it. And they also said that the reliance on theodolite lensing as an explanation was also not needed anymore. What they've done is they used AI to backfit their observations by using any means necessary. And they're still using stellarium as an FE simulator. So basically what they're doing is they're negating real world observations entirely in place of simulated observations using software that is also known to be wrong, software that was actually updated when observers during a recent eclipse had noted that the occlusion points of the eclipse and their timing was also off, and so Stellarium had to update their software to reflect that. So they're using software that is a toy, that is a hobby, and it's not based on precise astronomical observations in order to supplement what should be real-world observations they should have taken. But they didn't because, I mean, nobody wants to climb Pikes Peak in the middle of winter to take an angular measurement to a star. I get that. But the overall geometry is also bereft of any rigor because what they're proposing is parallel light to a flat Earth, when the whole reason for why people who believe in a globe believe an angular displacement over distance is due to parallel light over a curving surface. The curving surface is what gives rise to the parallax effect, why traveling over the curving surface increases or decreases the star's declination in your point of view, depending on your direction of travel. Now, when you have a flat surface and you have parallel light, the light source does not increase or decrease in angular declination or elevation based off of your distance traveled because it's parallel. Dr. Heffron twice claimed that that had to be the case for his model to work, which completely creates an incongruous model with reality, as well as a contradictory model with regards to Euclidean geometry. And that's what I argued in my paper, as well as the rebuttal. I asked for an audience in front of Dr. Heffron. They wouldn't put him through to me. And this is what they get. They get basically the shit end of the stick that I have to wield in front of them. And what I think is also ugly is I've got tons of backchat conversations. I'm not going to share them, but I'm going to summarize basically what happened. Over several months of discussions, they told me that, well, we are glad that we finally have a mainstream scientist on our side who can support what we've been saying all along. And if what we put in front of him was what you're telling us now, he might not come out in favor of our cosmology. In other words, they were willing to put this man, he's an older man with real experience. I don't doubt his expertise. They're willing to put him in front of the world in order to have an appeal to credentials. And they're willing to sacrifice the integrity of his observations and his conclusions in order to have that on their side. And what they've created was basically a very embarrassing moment for this man, his career and his legacy, which is something that I was hoping to help save them from. Now, thankfully, this work did not reach very far. So his integrity and legacy is preserved and rather relegated to a very narrow niche of the internet culture. But if it were to start to develop into something big, it would definitely cause embarrassment of untold proportions. And I think what they were doing, they were motivated basically by an appeal to authority. So they're willing to take this man and throw his life work under the bus and to cover up for the mistakes rather than address them academically and privately in order to get something out there that supports the FE cosmology. That's what happened. So, yeah, in fact, let me go through right now. I've got my directory up. I'm going to post some further information on this. Okay.
Yeah, I would have loved to hear about this, about what you bring up, like during their multiple theodolite review that they have.
Yeah,
But
what
that
are
was
they
on
on, version number 40 now? Like version 46? Because they keep moving the goalposts because it was broken from the get-go? Listen, they originally called this a celestial theodolite. And one of the models that Dr. Heffron produced was a measuring device used for stellar objects. And one of the things that they tried to use against me in my critique of this was to say there's no such thing as a celestial theodolite. We just called it a theodolite because we were using it for the stars. We said celestial. I'm like, that's not true. There are actual objects. There are actual devices called celestial theodolites. And I posted a couple examples of them. Used by the National Geospatial Intelligence Agency, used by astronomers, used by surveyors. And in fact, the celestial theodolite also has a nickname called the broken theodolite. Broken because the optical piece is actually to 90 degrees from a typical theodolite. A typical theodolite is basically a telescope. It's above a table with an alt-az gimbal on it. But what they do is they take that telescope, they use a reflector, and they bend the light 90 degrees to the eye so that the observer can be seated and look straight up at the stars with it, not have to crane their neck over for long amounts of time. Because let me tell you what, in the field, when you're observing stars and taking precise measurements, we're talking arc seconds of precision. You need to be in a very comfortable position. Otherwise, you're not going to be able to see the crosshairs. You're going to be bumping the optical device. You're going to be moving it around. It's going to be very, very frustrating. And so building it for comfort, they bent or broke the theodolite optic by adding that 90-degree reflector. And that was called the celestial theodolite. But they make fun of me today for this, saying there's no such thing. And I'm like, guys, there absolutely is such a thing. Right. So I'm going to go through here and find this information. I literally got a new phone like this weekend, and I'm going through the directories right now trying to pull this crap up. All right, so here we go. I think I called it celestial.
Do you trust your phone? Do you trust it?
Absolutely not. I don't trust my phone.
Oh, why
Do you
not?
trust your phone?
Yeah, it gives me the time and locations and stuff like that. Tells
Yeah.
me
Why
where
do you
things
trust
are.
that? Why do you trust that?
Because it works.
How do you know it works?
Because when I punch in an address, it takes me to that location.
Yeah, is it working in an optimal way? Is it working to the best of the ability of it? Or could it be even more optimal than the way it's working?
Why do you have it if you don't trust it? It makes no sense.
I trust it because it works, but I don't make any claims to the degree at which it's successful at working. What do you say to that?
You check the time on it?
Yeah, I mean, the time tells me whatever time that it's grabbing it from. I assume the Naval Observatory's atomic clock. What do you think?
Is it correct?
I don't know if it's correct, but I'll use it. Doesn't mean I think it's correct.
Would it be incorrect if we didn't account for time dilation from the satellite it operates or the cell phone tower that gets the information from the GPS?
Why would I have to do that?
Because it would be inaccurate. Your cell phone wouldn't
How do you
work.
know? To what degree is it going to be inaccurate? And how do you know that?
Because we know that time ticks faster up in space. Like the GPS satellite has to be accounted for that.
That's what you're saying, but how do you know that's true?
Because I showed you the experiment in the side chat.
What experiment was that?
The one with the atomic clocks?
Oh, the one that I refuted with A.G. Kelly's Scientific American article. That one?
You didn't refute it because you're using your cell phone. It works perfectly.
No, I refuted it by posting excerpts from A.G.
Cell
Kelly's
phone
article.
would never function if Einstein's theories were incorrect. It would not work at all.
Did
Do
you
you think
even
cell
read?
phones operate over satellite?
The cell phone tower gets it from the GPS, from location data. In
Oh,
time.
location data. No, we're talking about information transmission. None of this requires location data from a satellite.
But you said that you agree that the time, you trust the time on it.
Yeah, it has nothing that has to do with the U.S. Naval Observatory's atomic clock, which is broadcast by radio.
You sure?
Yeah, I am sure. I can give you the frequency that it's broadcasted on if you want.
Your clock on your cell phone, it would be inaccurate if it didn't account for time dilation.
Yeah, you keep saying that. How inaccurate, and how do you know that's true?
Because it works.
Yeah, but to what degree is it working? I keep asking you that, and you keep going
You're
in
using it,
circles.
aren't you?
I am, yeah, but that doesn't attest to the degree of accuracy.
Okay. Do you understand the difference? If Einstein's wrong, your cell phone doesn't work at all.
You keep saying that, but you're not substantiating your argument. I'm asking to what degree of inaccuracy, and you keep
time and
repeating yourself.
location on your phone, like we know this, right? Like it would be like the information on your phone would be completely wrong.
All right, guys. So at 7 minutes past the hour, I posted 2 clips of Dr. Heffron saying that he needs parallel light to a flat surface for his argument to work. And this is why the entire celestial theodolite observation is destroyed from his own claim. What do you think of that knowledge? I just took down a major flurf argument from the other half of this community. Yeah, this guy thinks time dilation is happening.
Yes, yes.
You know what? And even if it is, it doesn't prove your cosmology is correct. You know, I'm willing to challenge time dilation and also be wrong and still know that even if I'm wrong, it doesn't mean that your cosmology is correct. What do you think of that?
I still want to know if he still claims to be a pilot or if he was just lying about that.
Yeah, you know, let's go back to that. Yeah, how do you become a pilot? Knowledge. How do you do that? Can you walk me through what you did? Just very broadly. I don't need a lot of details.
Did you just make an
What made
elf
you want to
noise
become a
as a
pilot?
response?
Yeah, what made you want to become a pilot? Knowledge. What was it that did it?
I enjoy it, but this is getting like too close to home for me.
Really?
Yeah.
Why is that? Right. Because I'm asking you, like, what entices you
I
to
made
become a
it like
pilot?
the job and like home, man. I don't know you, dude.
You're not going to dox
Or
yourself by
listen,
telling us what kind of license you have or what you fly. Fucking
you know what got hey knowledge? I'll tell you what got me interested in ground school was the fact that my dad was a pilot.
You
Maybe
didn't
your
go to
dad was a
school, bud.
pilot too.
You're a terminally online guy. You didn't go to school.
Wait, you didn't go to ground school? Ground school's a prerequisite, dude. You didn't
did
know
not
that?
go to school. Okay, stop lying
No,
to me.
I went to ground school. I
No, you
didn't
didn't.
come
You're
out
a
with an
terminally
airman
online
certificate because I
guy.
didn't come. Listen,
You're a
I
flat
didn't
earther.
complete my training. I did not receive my airman
You did not
certificate,
go to school.
but I
Okay, you're an
completed
unemployed person on
ground school and I got
disability in the
hours
politics.
in a Cessna
No, you
152.
don't.
Yes, I
Did you just
do.
ignore
Like,
everything they taught you?
I went through ground schooling. And guess
So
what? I can tell you what got me through
are
ground
you
schooling. I can go into detail about this without doxing myself. You know what I did? I actually joined the Civil Air Patrol when I was a preteen and stuck through it when I was a teenager
No, you
through high
didn't.
school. And yes, I did. And that's what got me into ground school. I also started my radio operator's permit through that. And I did did a lot of crazy stuff at Civil Air Patrol. Do you know what Civil Air
I don't
Patrol
think you
even
did.
is?
Nah, I don't think
Civil
you did.
Air Patrol is an auxiliary of the U.S. Air Force. It's like Boy Scouts, but for
Ah,
kids who are interested in flying and search and rescue.
you can't fly, homie.
No, I can't. I don't have my airman certificate.
You
But I
never
seem to
went
know
to
more
school
about this than
because
you
then you
do, and
would
I never
understand what I
graduated.
told you
I never
earlier.
got through it. I never completed all the hours required.
Tell me what a two-dimensional manifold is. How do we take off from that? Tell me right now.
How do you take off from it? No, you asked me two questions. What is a two-dimensional manifold and how do you take off from it?
Tell.
What makes you think that Earth's surface is a two-dimensional manifold?
Huh? What's up?
What makes you think Earth's surface is a two-dimensional manifold?
What is a two-dimensional manifold? You should know.
Yeah, it's a surface whose position or coordinates on it can be expressed in two dimensions. You can use X and Y. Like the surface of a sphere, right? Surface of a sphere is two dimensions, isn't it? A sphere is a two-dimensional manifold. And what makes it interesting is it's a looping surface because
How did you get
Huh?
off the ground? Okay, the ground.
You're asking how an airplane works? I thought you were the pilot.
I'm asking you the surface of the Earth. Like, is it a run? Did you do a two-dimensional manifold is like a flat plane?
No, it's not actually.
If you say that
It's only a flat plane when you put it in a three-dimensional embedding space.
If you use it as an analogy, like if you say that your craft takes off from a two-dimensional manifold, enters into 3D space, and follows the geodesic, which you say the geodesic doesn't exist, then how are you navigating, dumbass? How are you navigating if you're not doing that? Like you're this is a politics, sir.
I don't know what you're talking about, dude. Like, have you ever heard of plane sailing or?
You have a whole bunch of talking points.
Holy crap, dude! How do you navigate? You can use your altitude and azimuth. Okay.
How are you getting from point A to point B? How are you doing that? Like we have waypoints in like the commercial industry, like right? There's waypoints. Those waypoints are what the geodesics are. Like right when we go like from waypoint to waypoint, like that's how we maximize our fuel efficiency and stuff like that in the commercial industry, right?
How do you know you maximize your fuel efficiency? By taking points that are not maximal?
Which is a straight line on a curved surface. The curvature of the Earth is the shortest path between 2 points. So if you want to travel the shortest possible so if I take like a route that's the shortest possible distance to my location, am I saving on fuel?
I don't know. Why don't you differentiate it from the alternative? Can you present that for us?
I would only do that for safety reasons.
So you can't demonstrate it for us.
Like I follow the geodesic when like there's not. Like,
how do you know you're doing that? Differentiate it for us. You said you're following this. Differentiate it from a non-geodesic path.
Curved, dude.
Differentiate it from a non-geodesic.
The non-geodesic? Well, then you would just go on the two-dimensional manifold on the ground. Like,
isn't that what you're doing, though? Isn't that what you said you're doing?
No, it's different on the ground.
No, it's different on the ground. I thought you believed in a curving surface in 3 dimensions.
Okay, but you're not. But on
so
the ground,
differentiate your geodesic from a non-geodesic right now. Show us the measurements.
From point A to point B?
Yes, exactly.
Well, like the geodesic, like when you're up in the air, right? Since you're following the curvature.
How do you know you're doing that? You keep coming back to this.
How do
you keep trying to put your conclusion into your premise. You keep trying to tell us that your claim is your evidence.
It's not a claim, it's the truth. I'm not.
How do you know it's the truth? Prove it. Prove it.
I did.
No, you didn't. I keep asking you to prove it, and you keep giving me the claim as evidence.
You want me to prove it?
Yeah, that's why we're here. Guess what? The second you do, guess what, guys? I will promise you this. The second you do this, I will shut the server down and our entire community, and we go away forever.
Okay. You sure?
Yes.
So if I
go ahead and differentiate. Yes, and I'll give you the conditions. Here are the conditions. You must differentiate a geodesic path from a non-geodesic path.
You don't deviate, motherfucker. You only do that for safety reasons.
Okay, so why don't you do it without safety concern? Because that's what I asked you to do.
Of course, I'm going to deviate from the path. Okay.
How do you know you're deviating?
How do we know?
How do you know you're deviating for safety purposes?
Because we're not following, like, the curvature, like, to perfectly, right?
How do you know that? I know you keep saying this over and over like a broken record. I'm asking you to prove it.
Because I'm following the waypoints.
How do you know the waypoints are curved or aren't curved?
How do I know?
Yeah.
Because how do I know? Because the Earth is curved.
How do you know that? How do you know? You keep saying it again and again, dude. Can you get off of your broken record and prove it?
Why?
Because if you do, I'll shut down the server.
You have a disabled person who's a moderator trying to tell me how to fly a plane.
Who's
said
that?
you were in the air. You didn't even know what a two-dimensional manifold was. That was
I
funny.
do know what a two-dimensional manifold is.
No, you
Actually,
don't.
you don't.
No,
You
you don't.
have no idea what a manifold even is.
You don't.
What's a three-dimensional manifold?
Three-dimensional, it would be like the Earth. That's three-dimensional.
What makes it three-dimensional?
What makes you three-dimensional?
Volume. Listen, I know this is rolled off the surface of my tongue. You know what the difference between a sphere and a ball is? The existence of volume. Volume provided by the embedding space for the two-dimensional manifold. If you take a sphere is actually a two-dimension manifold, and you put that in a 3D embedding space by giving it volume, then the sphere becomes 3 dimensions. Yep. Yeah, a sphere without 3 dimensions is two-dimensional because you can express your coordinates on the surface of a sphere using x and y only.
Yeah.
Yep, two
Go
dimensions.
Go on.
You had the third dimension, you had volume, and now you can express your position 3 dimensions with respect to a
What's the
north-south
fourth
axis connecting
dimension
the poles
and
of the
fifth?
sphere.
What's the fifth and fourth?
Those are beyond our ability to recognize. You know, we can describe them mathematically, but we can't intuitively understand. Or spatial dimensions. Or higher.
What would you say is more accurate, like a paper map or a GPS satellite system? Like when we're tracking, which we want to get from like our location, like at the shortest. What do you think is more accurate?
Depends. I mean, is the GPS system based off a paper map or not?
What if did you know that those paper maps were always wrong? You know why that is?
Yeah, I know why all maps are wrong.
No, just the paper maps.
All maps are wrong. Yeah, all maps are wrong.
Not the GPS. The GPS takes the curvature of the Earth into account.
How does it do that?
How does it do that? Well, that's easy.
And
like how do you think it does it?
I'm asking you. You sound like an expert, so why don't you talk about it? Tell us how it does it.
I'm a pilot. I'm not an expert.
Well, why'd you bring it up if you're not an expert?
Because I know that the paper maps were always wrong because they're two-dimensional objects and they don't take the curvature of the Earth into account because you can't draw like the three-dimensional object which is what the Earth is, like you said, into a two-dimensional object. So there's going to be distortions there, right?
So you're telling me latitude and longitude is wrong on paper?
So like if you're on the ground, you use a paper map. I'm using GPS. I'm beating you every single time.
How do you know that that's the case, though? How do you know which one is correct?
Because I know the Earth has curvature, and the GPS incorporates that into it.
Well, you can accommodate that on a two-dimensional map using a non-uniform scale, and now
No,
they're
you
the
can't.
same. So how do you know which one is more
No,
accurate?
you can't.
Yes, you can use a
You can't
non-uniform
fit a
scale. A
three-dimensional
non-uniform
object.
scale is how you account for it. It's how you
There's
account
going to
for
be
it's how you account
distortion.
for a spherical coordinate reference system
You
on two
can't put
dimensions. Use
like
a
a
non-uniform
three-dimensional
scale.
object like the Earth into a two-dimensional object, which is a
Have
flat
you ever
piece of
heard of a
paper.
non-uniform scale before?
Have you ever heard that you're
Have
an
you ever
idiot?
heard of a non-uniform scale before? Be honest.
Non-uniform scale. It doesn't matter.
It does matter. Maps use them all the time. You seem to be an expert on maps. Surprised you don't know
Okay,
about
hold on.
non-uniform scales.
Well, let's Google it. Let's see. Let's see if we're right. So if I Google this right now, it's not going to say that like maps aren't distorted, like the paper maps.
I never claim maps are not distorted.
Wait a minute. You said you'd shut the server down if I can prove that pilots navigate a geodesic. That's quite easy.
No, I said you can shut it down if you can differentiate a geodesic from a non-geodesic. You listen, you seem to have a learning disability because I said we will shut the server down if you can differentiate non-geodesic from a geodesic distance. In reality, go for it.
What?
I'm sorry, did I speak German?
What do you mean distance? What are you talking about? What distance are you talking about?
The distance covered by two coordinates.
A geodesic is just the shortest path between 2 points. You keep asking
Two
me for, like,
coordinates. Yeah.
distance,
Two coordinates.
dumbass.
Yeah. How do you know it's the shortest path? Differentiated from a linear path.
Because it's a straight line.
How do you do that?
How do you do that?
How do you differentiate it?
How do you differentiate? Yeah, because it's topology and, like, the curvature.
And like, so as like,
You do it. You tell me how you do it.
I didn't make the claim. This is your homework.
You said
It's your
that you
burden to prove,
fly.
dude.
You said that you were what did you say? You were in the Air Force? How do you
No. I said I was in Civil Air Patrol as a teenager, and I learned how to fly, and I never got my airman certificate.
You learned how to fly?
Yeah.
You
And a
were
Cessna
flying?
152 and a 172.
You're a liar.
And I also told the audience my dad was a pilot too.
You told the audience your dad was a pilot?
Yeah, I did. You may have missed that, and that's what actually got me interested in this in the first place. Because when I asked you what got you interested, you said it might
told
dox
me
yourself,
that you
and I
don't
said, okay,
navigate
well, guess
using
what? I'll give you a
geodesic.
personal story that won't dox myself.
I don't give a
My
shit
dad
about
is a
your personal
pilot.
story. I
Listen, and
know
that
that
got
you're
me
lying
interested
to
in
me.
flying because I used to
You
fly with him all
can't
the time when I was a little
navigate
boy. So it was great.
airline routes or any route you go to without the geodesic.
How do you know that's true, though? We're back to that. How do you differentiate that between what is not geodesic?
You mention it.
I'm asking you to help me understand what a geodesic is in reference to a non-geodesic. Differentiate them.
A non-geodesic?
Yeah, show me what happens when you don't follow a geodesic path.
What happens? You wouldn't be following a straight line.
Prove it.
Okay, we can do that. Hold on.
And how do you convince the audience that you're a pilot? What's one thing you could say that would totally like seal the deal? Because the audience is wondering if you're a liar.
Nobody cares.
No, the audience cares. That's why they want you to do this.
Who cares, dude?
The audience cares.
Your audience is fucking retarded like you.
Just say if you're a pilot or
boy.
not. Just say, yes, I am a pilot, or no, I'm not a pilot.
Like, you're a disabled person in the politics server. Okay, everybody knows the server's a joke, right?
Why are you here then? Because you're a joke?
Because you entertain me.
You're entertaining me. Listen, we got
I'm
a
here to
worldwide
laugh.
audience on multiple live streams right now. And
That's
we're
cool.
clipping this, man. This is freaking entertaining.
So this is honestly the only reason I was asking you, because I think it will be a funny title if you say that you are a pilot, which you already did. So I'm going to add it to the title, right? I just wanted to know because when I clip
I
this,
don't care. Nobody
right,
watches your videos.
I think it'll be a more interesting title if I knew what type
I
of
think it'd be
pilot
more
you are,
interesting
so whether you're commercial or not.
if, like me,
Right. So I'm going to DM you the clip after I upload it to social media. I sent you a DM, and you could share it with your friends and families and ask them to judge whether you did well or not.
I don't.
You don't have any friends or family? Oh, okay.
My friends or family. What?
Yeah. Let's say, look, I look how good I did in this
friends.
debate against flat earthers.
Blah 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 blah.
You didn't even understand what I said. I said you can DM it to your friends and family after we clip it, so you can show them how well you did against us today, and how silly you made the flat earthers look.
How silly I made you look.
Yeah, in your own mind.
I'm just having fun.
So, well, that'd be a first.
You think I'd take you seriously?
You've been in here for hours just getting wrecked on every single point, starting
Not
with the
wrecked.
lake test to every single test. Yeah, look, the audience
got
is going
wrecked.
to be the judge. Yeah, so your clip's going to get
cares
shared
about
all
your
over
audience?
social
Your
media,
audience is
and the
you already
audience in the comment section can be
this
the
would be like a
judge.
Trump supporter saying me, the audience, like, no one gives a shit. You're dumber than a Trump supporter.
Oh my gosh, he's so mad. Listen how mad he is.
Yeah, I think he's been well and truly broken. Another broken glober.
He can't walk straight anymore.
He's super emotional.
Dude, he was
too.
choking. He was choking on bong hits earlier. He's like, I'm choking on smoke.
You can hear the emotion controlling his mind. He can't
So let's go
control
back
his
to
emotions.
GPS. Hey, knowledge. Hey, knowledge. Since you love
mouth,
GPS so much, let me ask you a question. Like, have you ever looked at a Rhinex message from GPS before?
Have you ever looked at a Rhinex message?
Yeah, I have. Have you ever looked at a Rhinex message? What does it look like?
Nope. But you're a liar, though.
Why am I a
I don't
liar?
talk to you anymore.
I'm sorry. Okay. What coordinate reference system do
You bored
GPS satellites use? I can tell you.
Who cares?
Well, I care because I like GPS systems.
Who cares?
Do you know who manages the backbone of the GPS systems?
Me.
No, it's the U.S. Air Force out of Schraver Air Force Base, actually. They use an encrypted
If
network.
you're a disabled person on disability, as
Definitely
a
not
moderator,
disabled, man.
yes, you
I'm
are.
quite very much able. But even if I was
No, you're
disabled,
not.
why would it matter to you? Because what? You're an ableist? Are you a freaking bigot?
No, I just don't like Discord moderators
Yeah.
lying
What's
to
going
me.
to happen when you get old when you get like Alzheimer's and dementia? Are you going to be making fun of people who are disabled then? Like, is that just how you roll because you're an asshole? You know?
No, but you're lying to me, so you deserve it.
How am I lying to you? What did I lie about?
You said you went to school and college.
Yeah, I did actually. I got 2 advanced degrees.
Really?
Yeah, I do. Yep. Yep.
No, you don't.
What makes you think that?
Did you just ignore everything they taught you about, like, just about physics and like mathematics, or did you just?
No, actually, I critically examined what they taught me.
Really? So you got all the answers correct.
No, I just critically examined what they taught me. You know, nobody's going to get everything correct. I mean, duh.
You critically examined everything they taught you.
Yeah, that's right. That's why I believe what I do and I know what I do. It's because of that. Because I have a mind.
A flat earther has a mind. Just like
Yeah,
a
what
vaccine
are you a
denialist
bigot now?
claiming.
Yeah, what does it offend you that somebody has a different thought than you?
Does
Like, come on, dude.
Do you believe vaccines? Do you?
It has nothing to do with the topic.
But you're in the same category as these people.
No, I'm not. That's a wholly different
Yes, you
topic. What
are.
do you mean? This is the same topic.
You
We're
are
talking
just as
geometry.
bad as the
Listen, we're
vaccine
talking
denialist.
geometry. What does that have to do with
You're a flat
medicine?
earther.
Yeah, we're talking geometry. Flat has to do with geometry. What does that have to do with medicine?
Nobody cares about that.
Medicine? Well, you do. You brought it up as an objection.
Homie, like, you're acting like this is serious. That's your whole problem. You're funny.
Maybe it's not serious.
For
Maybe
all
you're
you know,
acting
I
like
could be a
it's serious and you're
multi-millionaire
triggering.
For all you know, I could
Why
be a
are we
multi-millionaire
talking
right
to
now
this?
triggering you. Just playing
Why are we
around.
talking to this guy? Like he's a horrible
I could
glober.
be
He
the
doesn't
biggest
even.
whale in the world
I know.
right
There's
now with
nobody
an
else to talk
audience
to,
10
Peter.
times bigger than you.
It's been slim pickings.
I
I
know,
feel like
but
I'm
it's
picking a
like
scab.
I think
How do you know you're not being trolled by a YouTuber?
I think you've
I feel like I'm
exhausted
picking a
this.
wart.
Yeah, we've
Seriously, let's
exhausted
have
this
some
one.
respect.
All right. Good point, Peter. All right, knowledge. Thank you for the content. I will DM you the clip once it's done. All right. Thanks for playing. You're done for the day.
I mean, the guy was such a poor troll. Like he doesn't even know the basics. You know, the surface of a sphere is 2-dimensional. He goes like, "You're leaving the 2-dimensional manifold," and then when asked, "Why wouldn't you go down the geodesic if you traveled on land?" he chokes.
I'm glad you caught that, Peter. That warms my heart.
Yeah, I mean,
welcome to the
that's
chat.
I mean, if I channel my past Glober, like I'd be so furious to have a champion like this, you know, who cannot even represent the globe model, whether it's true or not. I mean, Who are these guys? These guys are just. I mean, I respect a glober that knows his model. You know what I'm saying? I disagree with the model being wrong, but you gotta represent it at least consistently. If you just walk in and say, it's just these college bros, man.
Wait. You believe in flat Earth? Does that also mean that the price of tea in China is too expensive?
Yeah, because of geodesics.
I like how
It's called the geodesic tax.
Right.
You know, and just because you take a course on something, as I claimed I did, doesn't make me an expert either, and I still knew more than this guy.
Well, we know more about their model than they do. But listen, Yoder, just to be not to be a nerd, but isn't GPS technically maintained by Space Force?
Yeah, I guess nowadays it is. It used to be, I forgot which, an Air Force wing. But yeah, Space Force does it now.
I think globers forget that like flat earthers were globers. We probably know the globe model better than they do, and we actually asked questions.
Well, yeah, we were all globers, but also to become a flat earther, you have to look really closely into the globe model, right? Most people don't do that because they got better stuff to do. So we are, we're not average people to happen to become flat earthers. We're people who looked at the globe model very carefully and then found reasons to reject it. Most globers haven't looked at the globe model. They didn't feel the need to do so.
Yeah, then the anti-flat earthers, when you mention critical thinking, it kind of like baffles them. They're like, how? Critical thinking?
Don't you believe everything that people tell you?
That's what his response was when Yoder was like, yeah, I critically thought throughout my education. He's like, so you cheated? Or something like that. Oh, I laughed out loud.
You really can't make this stuff up.
You know what they say, life writes the best comedy. Yoder, I actually had a question for you. So Dr. Heffron assumes parallel light rays?
Yeah, it's one of the things I came to the conclusion of before he admitted it on McToon's interviews. Would you like to see the interviews? I clipped them and posted them in side chat, and I'll replying at you. Give me a second.
Sure, I'm not gonna look at them now. I'm busy, but that cannot be true though, because with parallel light rays on flat Earth, you would never see any motion of the stars. They would always be in the
Exactly.
same spot.
Exactly.
So So how would they? A star wouldn't get occluded by anything because it would just sit there in one position. Everywhere would be ground position.
Correct. There'd be no way to navigate. Period. End of story. Here, I replied and I added you. It's quite interesting. The clips are a little long, maybe about 30 seconds to a minute each, but you'll hear it in both cases. And it captured exactly what I wrote about in my paper that I addressed to him, not by name because I wanted to leave his name out of it, but posted the papers too. You know, these guys from the Aether Cosmology came to me, like I was saying, about a year and a half ago and asked me my input on this. And I told them exactly what I've been telling everybody now. I looked at the evidence. I'm like, yeah, you got parallel rays to a flat surface. You're also doing observations from within 3 degrees of the horizon, which is fraught with all kinds of astronomical or atmospheric distortions, rather. You know, and then one of your points of observation that you're comparing to in real life happens to be in stellarium. So you're not even using a real life observation compared to reality. So they're like, those are the 3 biggest issues I have with this.
Yeah, but those other issues you're listing, they pale in comparison with what I'm in so
Yes.
much disbelief that I suspect maybe there's a misunderstanding because, again, if consider the model, if the Earth is flat and rays are parallel, then the sun, for example, would be in ground position everywhere. Everyone would have sun in zenith. You know,
Here,
like in
let me show
Africa.
you directly from Dr. Heffron himself. I'll show you
Right,
a
but let me
diagram.
finish my thought. Furthermore, if all stars were parallel rays over flat Earth, they would all appear to be in the same spot. There'd be no angle to different stars.
Yep, that's the big one. So here it is, 50.7 kilometers difference between point A and B, and the same angle to the star at the same time.
He cannot mean that. We must have misunderstood. That'd be insane.
This is all over his paperwork. It's in his own write-ups he's done. This is everywhere, and he says it himself on the 2 clips that I posted. I know it's that bad. It is that bad. I've been telling these folks it was that bad before they went public with it, and they went public with it anyway, and it's even worse now. I'm like, oh my gosh, they're like, if we could have set up a private conversation like I had asked to between all of us, this could have been cleared up ahead of time. But they said that they were more interested in putting out Dr. Heffron in front of the community as one of us than they were in correcting his mistakes, because they feared that he would pull back from us if he had done so. And I said, well, then you're just using him. You're manipulating him for your own selfish purposes.
But in this
you know what, Peter?
diagram you
That's
just
exactly
showed,
what they did.
in this diagram you showed there are no parallel rays. The little star has a rays at different angles.
It's 2 degrees, 31 arc minutes in both cases, as they said in the paper, 2 degrees and 31 arc minutes.
No, but look at the line, right? Like there's a line that shows a ground position, you know, perpendicular to the surface, and there's a line to the observer, which is not perpendicular. So these are not parallel rays from the star.
Yes, they are. The second position is just elevated with respect to the other. Do you understand in air celestial navigation, the Air Force teaches this? It doesn't matter what elevation you are, that the star will remain at the same angle, whether you're at 0 degrees elevation or 0 feet elevation or
Rays are
35,000 feet.
parallel. Because rays are parallel.
Yes.
On the globe model, the only cause for the angle to a celestial body that's far enough, like sun and beyond, is the tilt of the Earth, not the tilt of the Earth, but your angle due to curvature.
What I'm presenting you is from his own diagram showing 50.7 kilometers of distance at the same time separated. The height is irrelevant.
I understand, but there's a line, like look at the top left corner of the diagram. That's a little star, right? It has a line going down, perpendicular to the surface, and it
Yeah,
has a
theta
line
F
going
is the
to the
same.
observer. And then it has a line going to the observer, right, at an angle. That's not the parallel, like a glober would not draw a star like this.
I know that. I know a glober wouldn't draw a star like that.
Because a glober would
That's the
draw
problem.
parallel
That's the
lines
problem.
falling on the surface.
Yeah, I know a glober wouldn't draw a flat surface, dude.
No, it doesn't matter. Oh my goodness. A glober, there are two different parts of this. One is what is the surface of the Earth, flat or curving? The other one is, are celestial bodies far enough that for all intents and purposes we can assume parallel rays? Those are two different things, right? You could have a globe with the sun very close and then rays wouldn't be parallel. They're not parallel from the moon because the moon's too close in the globe model. Like the moon being 230,000 miles away and the Earth being whatever it is in miles. Why do I do this to myself? In miles. Whatever in diameter in miles. Those are close enough numbers that you can detect angle differences. Even with the sun, we detect half a degree of an angle difference. In the globe model, they admit it. There's a half a degree difference on the edges of the sphere. So if a glober were to draw a flat Earth with parallel rays, that is not what they would draw. That's not what you have in this image. They would ridicule flat Earth and say, oh, look, the star would be in ground position everywhere on the
Yeah,
surface of the
exactly.
Earth. But
Listen
that's
to
not what he
Dr.
drew.
Heffron yourself. Huh?
That's not
That's
what
what
he
Dr.
drew. I
Heffron
assume
drew.
that
That's what
drawing is
Dr. Heffron, Peter, that's what Dr. Heffron drew.
okay, show me that drawing that has parallel like
I
this.
just did. That's what I showed you.
For the nth time in that diagram, there are no parallel rays from the sun, from the star.
The star should appear at a higher elevation angle when you're 50.7 kilometers closer to it at the same time. And that's not what they depicted here. And Dr. Heffron says it's not what he's saying either. He says they should be parallel. And furthermore, like I said, he used stellarium. So
okay, let me. I'm only asking you this because I want to get to the bottom of this one. The bottom right part of the diagram, where the triangle. I always forget the word vertex of the triangle, I guess. Right? Bottom right. Is that the observer?
that's observer 1, yes. And observer 2 is at
Okay.
Pike Peak, 50.7 kilometers away.
All right, don't worry about observer 2. Why is observer 1 looking at a star at an angle other than looking straight up?
I don't know, because it's not later in the night.
In the model where light rays are parallel, the full meaning of that is the object is so far away that when you look at it, there's no parallax as you travel over the Earth to the object.
Well, there is, and hold on. In the globe model, there is parallax due to the curvature of the Earth changing your angle.
I understand, but again, try to reason over two things separately. Flat Earth, parallel rays. What does that mean? It means that the object is so far from the flat surface that no matter where you are on that surface, you're looking straight up. Because if you move 1,000 miles here, 10,000 miles there, it makes no difference if the object is trillions of miles away. It's not
Right. Or
discernible.
50.7 kilometers here, 50.7 kilometers there. It makes no difference, as the diagram shows.
So a flat Earth with parallel rays has the star in zenith everywhere on Earth. That's the joke, right? That globers make about flat Earth when they forget that we don't believe that objects are so far away. So,
or we don't believe that objects are even objects that could be triangulated.
let's leave that for later. So basically, what he drew there is not that, is what I'm saying. Because when you were talking about this, that Heffron claims parallel rays, I imagine this globe radical with a flat Earth and parallel rays. But that's all what his diagram shows, so he must mean something else. We misunderstood him.
No, he didn't say that in his interview with McToon 2 times, like I posted.
I'm not questioning your report on the words that he uttered in the interview. I'm looking at the diagram, and if it came from him, then it doesn't show parallel rays.
Yes, it does, because it's going to be 2 degrees 31 arc minutes at the surface as it would be on Pikes Peak.
Dude,
if you're to take an
line,
elevator from Pikes Peak down to the bottom of Pikes Peak and could look through the mountain itself, it would still be 2 degrees 31 flat or globe.
bottom right of the diagram, I'm staring at it right now. There's a theta G angle of 2 degrees and 4 minutes. Yes?
Yeah, that's not what he's referring to. The actual observation was 2 degrees 31 arc minutes.
Okay, fine. Theta F then. So that line, the black line extending with the blue line, right?
Yep.
That's the line of sight from the observer to the star. Yes?
Right.
How are the light rays from the star parallel?
Because
did you see this?
Listen. If because he moved 50.7 kilometers towards it and it didn't raise in elevation.
What?
Because in the real world, if you move vertically, stars do not change in elevation.